All right, guys. So my name's Dan Rossi, owner and operator of Rossi Home Inspections, located in Long Island, New York. We're going to talk about how to inspect HVAC systems. Going to go over heat pumps, air conditioning systems, and everything in between. So I'm going to just kick it off and get started here now. All right. So first thing we're going to go over is all your InterNACHI, home inspection standards of practice. So things that we should be inspecting, and then obviously things that we shouldn't be inspecting, right? So our home inspections are always normal operating controls. Test the thermostats up, down, make sure heat and air conditioning are working. All right. We're going to describe where the thermostat's located, the source of the energy, and then obviously the method that is heating the home. All right. And then if it doesn't work, obviously we'll note those defects in there as needed. All right, so we're not required to do is inspect or evaluate any of the flues or chimneys, chambers, heat exchangers, combustion air systems. We're not going to do any makeup airs, humidifiers, dehumidifiers, electronic air filters, geothermal systems, solar heating systems. We're not inspecting any fuel tanks or underground or concealed fuel supply information. We're not going to determine the uniformity, temperature, flow, balance, or distribution capacity, any of the BTUs, supply adequacies of the heating system, or we're not gonna light or ignite any pilot lights that are turned off. We're not going to activate any heat pump systems or other heating systems based on in temperature air. You don't want to damage any of those units. All right. We don't want to override any electronic thermostats or obviously mess with anybody's programmed thermostats. We don't want to. We want to evaluate. Not required to evaluate the fuel quality. All right, and then verify the thermostat calibration, heat anticipation, or automatic setbacks. And then we're not going to be measuring or calculating any airflow, ventilation, or dilution of the flue or gases or anything like that. All right, for cooling purposes, right, we'll inspect the cooling, again, all based on not normal operating controls from the thermostat. And then we'll provide where that thermostat's located and the type of system and method of cooling. All right, we're not going to, we are going to talk about any issues that why it did not operate, and then if the cooling system was deemed inaccessible as well. We're not required to determine the uniformity, the temperature, the flow, the balance, the distribution capacity, any of the BTUs or anything like that as well. We're going to inspect or determine the thermostat calibration as well for the cooling as well as the heating. All right. We're not going to examine any electrical current, coolant fluids, or gases or leakage. All right. So introduction to HVAC system. Oh, sorry, guys. I just messed this up now. My screen. Where did my slides go? No. Sorry about that. All right. So introduction to HVAC system. So ventilation became an important during the Industrial Revolution in order to protect the workers. All right. So air conditioning is relatively a recent development, invented in 1945. And then became widespread there after that. And now everybody needs to have their air conditioning, right? You can't live without it. And today's air conditioners have gotten more complicated over time because now they deal with temperature, humidity, moisture in the air, cleanliness. So there's a ton more that goes into HVAC than used to in the past. All right. So here's a quick video from Jim. I'm going to play that and we'll let that go here.
Inspector shall inspect the heating system using normal operating controls. The inspector shall describe the location of the thermostat for the heating system, the energy source, and the heating method. The inspector shall report as a need of correction any heating system that didn't operate, or if the heating system was inaccessible.
Okay, we're going to start section 3.4, the heating portion of the inspection. On this particular house, we have a furnace. You may have a boiler. You may have a heat pump. There just depends on where in the country you're living, what you have. But typically what we like to do is first things first, go to the thermostat, do a visual inspection, make sure that we can actually adjust it. Newer furnaces, a lot of times now we're coming to furnaces or thermostats that the seller has locked. So part of our seller notice that we do before the inspection is asking them to unlock their thermostat so we can actually adjust things. If it is locked when you get here, you're not required to bypass it. Don't get in the habit of taking it off the wall and jump ring wires, things like that. Sometimes we'll have the buyer's agent to call and see if the seller can unlock it with his phone. But so this is a electronic. So we right now go to heat. We turn the heat on. Upstairs, we turn on the furnace. So we come down, it should be operational. This is a category 4 high efficiency furnace. We can tell that because we have plastic, flue, and combustion air. So it's a direct vent. This one happens to be a carrier. So now that it's running, we know the furnace is operational. So now we can start our inspection. What we do is we're going to turn off the disconnect. There's supposed to be a disconnect between the door and the furnace, and that's for safety. When we do that, then we'll take off the cover plate, put it in a safe location. At this point, we would start looking at our flue. Since this is a direct vent, we have a flue and we have our combustion air. So we have 2 pipes. These pipes are PVC. We're not code inspectors, but code does allow for PVC flue materials. Most of the the PVC manufacturers do not recommend its use as a vent product. In my report, I note that there have been documented problems with PVC. When we do use PVC, however, we have to have a purple primer, just like they have here, just like when we use it in our plumbing systems. Now, as it goes into the ceiling, we can't see it. We will look to see where it discharges if it's a safe location, but we will also note portions of the furnace flue were not visible, accessible for inspection because they disappeared. In the basement, we looked at the furnace and we could see the flue on that side. Now, this is what comes out of the house. This is the combustion air. This is the flue. It's a little unconventional to have it this far out, but they're supposed to be 18 inches apart. Typically, we want to see screens. Most jurisdictions require a screen in the flue and the combustion air. In Colorado, we don't put it in the flue just because of condensation freeze up. But so combustion air, flue. Flue should always be higher than the combustion air so we don't just recirculate that exhaust back in. But so this is our furnace flue, furnace combustion air. Inside the furnace, you're going to find the data tag. We take a picture of that on every inspection. That way, we know what was here. We're going to take a picture as we take it apart. We want to make sure down the road somebody could change this out. And so we did the inspection on a carrier. They may call and say, hey, we have a problem with our furnace, you didn't catch, and it's a ream. And it's like, well, that's not the furnace we inspected. In our report, we're going to document model number, serial number, BTUs. You are not required to do that by the SOP. So that is exceeding, although it is pretty handy for clients when they're calling an HVAC guy to have service work done, and they have all that information. So now, as we're looking down here, we have an inducer or a draft fan. We have a gas valve. Because it's a high efficiency furnace, we have a sealed burner chamber. We do have an inspection glass here though. So when we turn the furnace back on, the first thing we should see happen is the draft fan should start spinning. Its job is to force our exhaust out. Then on this particular model, we have a glow plug or an igniter. Sometimes you'll have a spark plug on a high efficiency. We don't just have a standing pilot anymore. But so when we look in here, we'll see a glow. After that glow gets really hot, we'll hear a click from the gas valve. That'll turn the gas on, and then we should light our burners nice and evenly. If the burners do not light properly, there's a flame sensor that won't get hot, and it'll turn the burners back off. That's called a short cycle. So we're going to turn on the service switch here so you can actually see how this is supposed to operate. And it takes a little bit when we do this to go through its test. So here, the draft fan comes on. So that's gonna come on for 30 seconds. Up here now, we wanna look for a glow. There it is. We're just starting to see it now. Come on. I like to put my finger on the cylinder. There's the click. When we hear that click, now we should light our burners. If the burners don't light, typically the draft fan will turn back off. If the burners light correctly, we should run. The burners will get the chamber hot, and then in about a minute, the blower motor will kick on, and then we'll start putting heat through the house. Another thing is not part of a standard of practice. We are not required to check for carbon monoxide. If you choose to do so, this here has an accessible plastic plug where you could put your carbon monoxide probe. Sometimes there'll be a little test port where you can put it in. You do not want to disassemble something to check for carbon monoxide. You can also check at the closest register. But that is exceeding the standards of practice. A lot of home inspectors do a carbon monoxide test, but you are not required to, as we are visible home inspectors. So now our fan kicked on. As we're looking at our gas system, we want to see black iron in to the furnace. We never want to see a flexible line going into the shell. Here in Colorado, if we're on a concrete floor, we have to have flex line now. So we're looking for that. We want to shut off. If it's newer than 2014, that you can do with your hands. And down here, each appliance has to have a drip leg or a sediment trap near the appliance. So this one actually runs both the water heater and the furnace. That is acceptable, but it just needs to be near the two of them. Down here, there'll be an air filter. So everything's operating again. So this is when we put things back together. When the system was off, we looked at our air filter. Now, as the system warms up, we will use one of our small infrareds, and we will go and check that we have heat at all of our HVAC registers. Coming in here, on this house, in this room, every room should have heat. There, we can see it right there. On this one also. Now, when we're looking for a basement, if it's a finished basement, we should have a return. So each level of the house has to have a return for the HVAC system to function properly. Again, coming in here, each room has to have a heat source. We have it right there. So it's getting hot. Interior bathrooms. Most jurisdictions do not require interior space bathrooms to have a heat source. So you will find a lot of bathrooms that do not have heating. If it's on an exterior wall and there's no heat source, in cold climates, we write it up because you can't have a freeze problem for the water lines. And now we would just go through the house and check all our registers. Okay, here's another one. We'll actually check the flow. Make sure we have airflow also. Just because you have heat doesn't mean you have great airflow. You're not required to use an air meter. So we personally don't. But as we're going through, we see with this, if we have one that's cooler than the others, then we will check and see what kind of airflow we have to it. In this room, there's one right here. Again, we have nice airflow. There may be one in the back corner. Sometimes there's one by the window, but again, I'm not going to move a couch to try to find it. Here's our returns for this level of the house. This bathroom has one, so we're going to check it there. Bedrooms, we want a heat source in every bedroom. And again, usually they're located beneath the window. I'm not going to move the bed to find it. So the report's going to say the HVAC registers were not visible, accessible for inspection due to the occupant's belongings. Now, this brings up a good point. Sometimes you will come to a house and they have a room locked. Unless somebody provided you the key, you're not required to inspect that room. You do definitely want to document the southeast bedroom door was locked. Therefore, the southeast bedroom and all interior components, electrical, etc., could not be inspected, could not be verified. So you are required to say what you cannot inspect. So in this house, that's what we have for our HVAC ducting. Now, we take a picture to start with a thermostat, especially when we can adjust them. And when we leave the house, we take another picture showing that the thermostat is exactly as we found it, back to 68 or whatever the client has it. Just wrapped up to 3.4. Now we're going to start on our cooling system.
All right, guys. So Jim does a really great job explaining on breaking down a category four furnace there. Another thing I like to do when I do my inspections of your HVAC is also when you have a return vent that has a filter in it. You should open that return vent and check, make sure that's a sealed return vent, right? A lot of times you have the return vent inside the air conditioning unit, but a lot of times we see them at the filters are at like locations within the room. So open them up, make sure they're sealed. A lot of times people are just cutting holes in floorboards or using chase walls, and that's pulling a lot of that debris inside, the coils and dirtying them up because the filter isn't protecting those areas. All right. So we'll jump into the next slide here. All right. So we're going to go over some heat fundamentals, right? So you have th three forms of heat, right? You have radiation, and radiation is the transfer of heat of electromagnetic waves through motion, right? Usually that's the sun, all right? And you'll feel a room that has a cold floor and walls and heats. The amount of heat loss from your body in that room depends on the relative temperature of the objects in that room, all right? Radiating heating is residential building includes, piping, electrical wires and floors, walls and ceiling. Radiated heat emits in all directions. And with radiator heats, right, you want to make sure your baseboard covers aren't blocked, right? A lot of times we'll get to the house, especially now, it's starting to get cold. A lot of people close theirs in the summertime, and then you want to open them back up so you make sure you're getting that heat flow through because the air's got to flow through the bottom, and then as it heats up through the radiators it'll emit and come, through the room. Conduction, right, is the heat transfer from one molecule to another or through one substance to another. It is heat that moves from one body to another by direct contact. For example, heat is transferred by conduction from a hot boiler, a heat exchanger, to cooler water passing through it. All right. And then there's convection, right? So convection is heat transferred within a gas or a liquid. All right. And this is pretty good, depictions of what that is, right? Um, and heat rises, right? So we're always checking that as well. All right. Let's go to the next slide here. All right, so four furnace categories. So Jim went over a category four furnace. So category one vented appliances is an appliance that operates without a non-positive vent static pressure. So that's something that just vents through gravity. All right. Um, right. Vented number two, an appliance that operates with a non-positive vat extent pressure and with a vent gas temperature that can cause excessive condensate production in a vent. All right. Category three is any vented appliance with a positive vent static pressure with a vent gas temperature that avoids excessive condensation. And then four, which we saw there, is it's just your typical gas vent temperature that can cause a ton of condensation. All right. Um, All right, so here's a better depiction of a category one, right? Is your conventional gas furnace. All right. Operates with the flue at a neutral pressure or a negative pressure with respect to the combustion appliance zone. So the room in which the furnace is located and the stack temperature is hot enough to avoid condensation in the vent. The burner draws its combustion air from the CAZ, the combustion chamber, is also open. If you're standing next to the furnace, you can peer in and see the burner and the flames. So I always like to take a look and see, make sure you have a nice blue flame on any of your burners or your heat exchangers, right? Because I always like to notate if your unit needs to be serviced, right? If you see an orange flame or a red flame, that's an indication that it might be dirty or dusty, or needs to be maintenance. So it's always good to look and make sure that it's burning. We're not expected to determine if it's adequate, but if it looks like it needs to be cleaned, you want to notate that. All right. So older category one furnaces, they use an open draft hood that'll allow air to pull into the vent. All right. And that helps with the drafting. Newer furnaces replace those draft hoods and you'll see that like round, like cone shaped fan. Okay. And that'll help draw air in and help with the venting of gases. All right. There's usually like a diverter in there and it's directly on the chimney flue, usually right above those burners. The newer type of category one furnaces replace the draft hood with a small fan, like I said, and that helps pull that air. Um, just moving on to the next category of units here. So category three furnaces has a vent pipe that's under positive pressure, and the furnace is non-condensing, meaning its flue gases will only go through one heat exchanger, then exit through the vent at temperatures above 140 degrees. All right. These appliances can produce condensation. All right. Although they're not considered to be condensing appliances. Category three appliances vents through the wall or a roof and is a forced draft, meaning it's equipped with a combustion fan. All right, so those are those power vent fans. You'll see them plugged in. And that's located before the burner to help push the air through the combustion chamber and then out of the vent. The fan is continually operating when the burner is firing, so the vent stack pressure is always positive. Okay. The vent system flue must be airtight. Category three furnaces vent their exhaust gases outside through a sealed pipe, so they cannot be backdrafted. They're typically installed as sealed combustion slash direct vent appliances, meaning they draw the they draw their air directly from outside. So usually you'll see the two flues coming out of the sidewall, sometimes through the roof. Okay. And those need to be a certain distance apart. Jim said 18 inches. I would check with your jurisdiction on that. It might vary. Okay. And there's going to be different spacing around air inlets, gable vents and things like that. So you want to look out for those as well. All right. So category four furnaces are combustion appliances that have a vent pipe under positive pressure and flue gases under 140 degrees. The vent exhaust is so low temperature because all category four appliances are equipped with a secondary heat exchanger where heat is then further extracted from the combustion air as the water vapor, and they use that as a byproduct, and it helps cool and condense to a liquid water. All right, this liquid is drained to the outside, so you usually see a condensate pump, draining it, or if it's in the attic, you might just see a condensate line going out. Um, so the local codes, depending on yours, require that it be pre-treated before disposing to the sewer. So you'll see sometimes it has that charcoal canister on there. Okay, you can look for that as well. Because the combustion gases are going directed through that secondary heat exchanger. And because they're extracting all that heat, you have more products that are in the gases and stuff that are broken down in that water, and they have to be cleaned. All right. There's also category four water heaters, which you're going to see too as well. So they'll have those power vents and they also will vent with PVC or CPVC as well. All right. Like category three furnaces, category four furnaces are forced draft, meaning they're equipped with a fan, and you'll see them turning on first, pulling that air out and pushing it out, and push the byproducts of combustion through the vent pipe and outside. Category four furnaces should be installed as a sealed combustion and slash direct vent appliances, which means their combustion chamber is sealed off. So when you open it up, you won't really be able to see much in there. Okay, there's usually going to be a little glass that you can look in through, because nearly all of the heat in that unit needs to be gone through the heat exchangers. They prevent the loss of that, and that's why you don't have any. That's why it's all sealed. All right, so as an InterNACHI, right, a member, right, we want to follow the standards of practice, and we want to identify and describe what type of heating systems, all right, the fuel systems that's used, So, most inspectors, right, to describe different types of heating systems. So typically it's air, it's going to be water, steam, electric. All right. Those are the most common types that we see, that I see in the Northeast. I'm sure that there might be some other types you might see. So you want to definitely, notate those down. And then there's your four types of heating systems. So your warm air, your hydronic, your steam heating systems, and your electric as well. You want to notate that. Most heating systems can be described in these four ways. An inspector really wants to describe the energy source of them. So if they're fuel oil, if they're propane, natural gas, coal, electricity, wood, kerosene, pellets, any type of heating system, you want to notate that in your reports. All right. I also take, like Jim said, a picture of the serial, the data plate, and I always like to take a picture of the units themselves and all four sides because you want to notate the overall condition of those units, if anything's damaged. And like he said, you never know. Crazy things have happened, but you do the inspection. There's one type of system there, and then some happens where it gets switched out. Never heard of a heating system getting switched out, but I've had this has happened to me on appliances. I always take pictures of the appliances, and you want to make sure that this is the system that you inspected. So if someone calls on it, you can identify like, well, this is not what I inspected or saw there at the time of the inspection. All right. So gas meters, right? A lot of houses are utilizing natural gas or propane, but we'll go over natural gas right now. So obviously it's a no color, odorless, and it's not toxic natural gas. Okay. It, however, is highly combustible. All right. It only smells because the scent they actually add back into it. All right. Well, not most, but all of your providers will do that. Um, and then natural gas is actually lighter than air, so it will, right, raise up into the house. Okay. Propane is tends to pool on the floor. It's much denser than air. So just think of that. Propane goes low, natural gas goes high. All right. To ignite natural gases, you need it obviously, or any gas, you need to have a good air mixture. So that's why a lot of those furnaces will pull air in from outside. If you have too little air, right, it's not going to fire. If you have too much air, it's not going to fire. So you have to have between 86 to 94% of air mixed with a certain gas volume to get the gas to ignite properly. Once ignited, the ignition temperature of natural gas is 1200 degrees. All right. So it gets really hot really quickly. In a conventional gas furnace with a natural draft, air is mixed with the gas initially for combustion. The air is called the primary air. Primary air is controlled by the air shutters at the front of the burner assembly. The remainder of the air mixture comes from the air that actually surrounds the flames inside the combustion air. And that's going to be called your secondary air. The secondary air around the flames and the primary air are then drawn into those burners and combined to make up your total combustion air. All right. A gas meter, right, is the device usually located on the outside of the houses. Sometimes it can be found on basements, garages, things like that. And used on most residential and commercial buildings. They're owned by the gas companies. Okay, they set them there, and that's to obviously monitor the gas that comes into your house. There's tons of different designs you'll see, but you want to make sure that the gas vent, right, is vented outside the house. All right. Sometimes they'll just leave the gas vent and it vents into the house. You want to make sure that that regulator vent is outside. We're not really required to inspect the gas meters, but I have had that happen where a new construction house, they didn't vent the gas meter outside and they would not provide the people with gas. It was notated in the report, but they didn't really understand what it was that they had to call the gas company. They told the builder about it. He didn't do anything about it. And when they moved in, they would switch the gas in their name. So you want to make sure it's vented outside. Um, right? You want to look at the overall condition of the meter, right? Rust, damage. A lot of times, if you find your gas meter that's located in your driveway, you want to make sure that's protected with a bollard, to prevent any damage. Same thing if it's in the garage, you want to make sure it has a bollard or adequate protection. from any physical damage, because obviously a gas meter, if you gets damaged, it can be a problem, right? At a gas meter, there's going to be a check valve, a main valve there, and check for the main valve there. The main gas valve usually is turned off with like a wrench. It's not like a simple ball valve or anything like that. Um, but there should be a spot where you can lock that, or it can be locked by the gas meter company so that it can be made safe. All right. The gas service line from the street to the gas meter may be made of plastic. You'll see metal. Um, it's usually obviously subterranean, usually about 15 to 20 inches below the grade. Can vary depending on your jurisdiction. All right. You should not see the plastic gas service line come to ground level though. So even if it is get plastic, you won't see it. It should be metal coming out of the ground. All right. And then a lot of times you'll see this yellow wire usually that's wrapped around it. And that's a tracer. So that's used by I want to say PSE&G, but used by the gas service providers so that they can trace out that gas line. So you'll see this copper wire that runs around. It's usually not connected to anything. It's just wrapped around the pipe, and they use that to locate them. Right. And when you look at your gas meter, you want to make sure. I always check the gas meter when I'm outside, and make sure it's not locked or turned off. Right. You never want to turn that gas meter on or off when you're inspecting it. Obviously, if it's turned off, it's probably turned off for a reason. So turning it back on, could cause damage or harm to people. All right. You also want to make sure that shut-off valve is readily accessible. I always like to notate a lot of people plant bushes around them so you don't see the gas meters. But then if you have to turn it off in a hurry, it's you can't find it or the fire department can't find it. So you definitely want to make sure that it's um, visible and accessible. And you never want to put it in an unvented location, like in a closet, some sort of area that isn't vented. All right, so gas piping. All right, bunch of different gas pipings installed before the meter and then the meter itself. It's usually the responsibility of the gas company. The gas piping installed after the meter is going to be responsible for by the homeowner. So everything to the gas meter is gas company. Everything past it, obviously, homeowner. Most common type of gas pipe you're going to see is black iron. All right. Some jurisdictions allow for copper or brass, stainless steel tubing. You'll see the corrugated copper as well. That'll have like a yellow sheathing and it'll look ribbed. That's used in a lot of areas as well. You want to make sure that you're using the proper tubing, right, or piping. Um, Underground piping is usually type K, and usually it's lettered on the piping. Obviously, if it's underground, we're not going to be able to see it, but if you do get a chance to see if it's while it's going into the ground or coming out of the ground, you want to make sure it's the proper one. Um, the corrugated ones that I was talking about, you're going to see a lot of them connected to appliances, right? So most of the time it'll be hard piped and then from the appliance from like behind gas dryers or behind gas stoves. So you're able to pull them out a little bit and shut them off and disconnect them. And they are allowed not allowed in some jurisdictions. So you have to watch out for that. But most do allow it. And then also too, you want to make sure when you're looking at your pipes that you don't see Teflon tape. You want to see actual pipe dope on there. They do have a gas one, but it is yellow. So if you see white there, you know that it's Teflon tape. The Teflon tape is going to break down. It's not recommended to be used on gas pipes. You want to use the proper, gas sealant for gas valves. Also, different sealants are going to be allowed for different types of gas. So if you have propane versus regular gassing, regular natural gas, it's going to be different. It varies. Um, Most jurisdictions not allow the use of gas piping as a way to ground the electric service. So where I'm located, we don't find any gas bonding here. I know in some jurisdictions they do bond the gas pipes, but we don't have that here in New York. And most you don't want to rely on that as well, as a primary means of bonding the electrical. And they'll talk about bonding in different sections, but bonding the gas pipes to the electrical ground system is a requirement in some jurisdictions. But I don't see that. So the bonding is usually done by connecting the gas pipe to the water supply piping that is near the water heater. That is assuming that the water pipes are grounded. So the water pipes have to be grounded properly as well. If there's a leak, you may smell it, a gas leak, right? The leak could be coming from a valve, a loose connection. We always see those old style butterfly valves. I feel like 7 out of 10 times those are the culprit of leaking, or at a union. You'll see that's where like the two nuts go together when they usually will bond to the gas pipes together. All right, so check those with your gas sniffers. Um, I have actually two gas sniffers because I never trust it, especially when I smell gas. But it's not required by our standards of practice, but it's definitely a good tool to have in your tool belt, and people will appreciate it. All right. Black steel, right? Galvanized steel is commonly used inside residential properties to carry natural gas. And sometimes you'll see it with a zinc coating, so it's not gonna be black; it'll be like that silver color. Um, all right. And galvanized steel is not to be used on gas pipes, excuse me. So galvanized you'll see the zinc coating, but galvanized steel you don't want to see with gas pipes. It'll look like a water pipe, and that's bad. Gas, you never want to use that. If copper is permitted, both the water and the gas piping may be copper. You has to be specially identified. Okay, so usually they'll have like yellow tape on it, or it'll say gas line on it. You'll see. The drip leg. So in the video, you saw Jim talked about it. That's when there's a T at the pipe and there's actually an extension on the bottom of it before it enters the unit. That's because gas has sediment in it. And inside that drip leg allows some room for any sediment as the gas is coming down before it enters the unit. It'll drop into that drip leg there. Okay, so you want to look and make sure that drip leg is there, all right, and that will prevent any damage to your burner, all right, or your really your gas valve. Um, and the gas shutoff valve should be installed adjacent to your furnace or boiler or heating system, all right, and every single unit should have its own shutoff valve. All right, you never want to have one shutoff valve relying on say two units. You want to be able to individually turn those units off, okay, separately. So here we're going to get into the combustion fundamentals, all right? So obviously the combustion is the burning of all your byproducts from heat, all right? Energy being removed from that unit and going out. Combustion, you really want to safely and adequately remove it from the unit. You never want to have any leaks or damage to your flue vents. Um, so natural gas is about 85 to 90% methane. So burning natural gas with oxygen yields carbon dioxide, excuse me, and water vapor and heat. So we get heat, but we got to get rid of the bad stuff. In reality, air is the source of oxygen, and in the air, oxygen is mixed with some nitrogen. And the result, flue gases from the combustion will contain some nitrogen. All right, combustion is never complete or perfect. In common and combustion, exhaust gases, both unburned carbon as soot and carbon compounds, will be present. Also, because air is the oxidant, some nitrogen will be oxidized in various nitrogen oxides. All right. The exhaust gases can also include chemical combinations, right? Since natural gas is burned with air, which contains oxygen, nitrogen, traces of gas. The exhaust can also include carbon monoxide, oxides of nitrogen, and if sulfur is present in the fuels, it could lead to sulfur dioxide. Um, There's also the dew point that you want to get kind of familiar with. So that's the temperature below which the water vapor contained in the flue gases will be turned into condensate, right, into a liquid. This is often referred to as condensation. So there's always going to be some form of condensation during the combustion process. If a chimney or venting material falls below the dew point temperature, right, condensation in the flue will occur. The dew point can be measured if a technician sees it. That's not going to be on us, right? But you want to note if you're seeing a lot of condensation or water dripping from the flue. So that's something to definitely notate. All right. If you see any corrosion or rusting of the flue or damage from water, that might be an indication that there's too much condensation in there. All right, combustion air, roughly 15 cubic feet of combustion air are needed to burn 1 cubic foot of natural gas. Gas furnaces, just like oil furnaces, they need to draft, right? You need air to get the proper combustion gases out, right? So another 15 cubic feet of dilution air is needed for every cubic foot of natural gas. This air helps with the chimney draft, right? Again, we're not testing for draft. It's actually a simple test, but our standards of practice do not require us to do that. Um, but if combustion air is inadequate, right, supplied to the gas furnace, likely you're going to get carbon monoxide. I always wear a carbon monoxide detector on me. So when I go into a house, that's the first thing I turn on, carbon monoxide detector, just to make sure there's no issues, right? You never want to have that. So I always recommend that all my guys wear it, and it's, the best. I don't trust if they say they have carbon monoxide detectors at the house that they're actually functional. All right. So your different draft types here, right? So there's three types of burners relative to the draft. You have your natural draft burners, your induced draft burners, and also your forced draft burners. Okay, so you can see the natural on the left, the forced in the middle, and then the induced draft fan as well. Natural draft refers to the burners, conventional, mostly low efficiency burners for gas furnaces. And this is also called an atmospheric burner. With natural draft, we need to keep the chimney hot enough, right, to get those combustion airs and gases out into the chimney. A forced draft describes a furnace that has a fan. So that fan will kick on and it's going to help push all that combustion air out up the chimney. And it doesn't require as much heat, right? So you can use more heat for the unit and inside the house. An induced draft uses a blower fan to pull air into the burner during that. So you'll see that has that extra vent usually coming in for combustion air. And when the fan induced is operating, there's a negative pressure inside the heat exchanger. And then the drafts are also, a power vent, it's also called, that will pull that air and into the other exchanger and before the vent pipe and then send everything out. Um, so those are your three main types of draft types. You never want to have backdrafting, right? That's when the air isn't coming up the chimney and or out the vent. So that's coming now back through the unit and into the house. All right. And that can be dangerous, right? Because that's pushing carbon monoxide, carbon dioxide, sulfur oxide back into the home, which could potentially be fatal. All right, so you're always going to want to take a look at, make sure that the chimney isn't blocked, it's not damaged, that it has the proper heights, right? And anything that can restrict the airflow out, right? You want to prevent from backdrafting. We want to comment on that. All right. If there's any damage to the flue pipe or even improper pitch, we see a lot. Okay. So you want to make sure the clamps are all tight on all the PVC, right? That's another thing that we see a lot, especially in new constructions. Guys just put the clamps on there. Now air is being pushed back in. It's not allowing them to draft properly because it's not sealed properly. Also, a lot of these units, right, they shove them in closets and things like that. You need to have proper combustion air. They need to be properly ventilated in that space. All right. So it's all going to depend on that volume of air and based on the BTU of the unit. Again, not something we're going to be commenting on, but if you see a unit is in a closet that seems too tight and then there's no combustion air for it, you may want to notate that to be looked at further. All right, so you really want to have two if the heat exchangers in a or the furnace is located in a closet, there should be two or at least one form of ventilation, right? To outside. So a lot of times you'll see a vent on the outside of the house, a high and a low, and that'll allow that air for that combined space. So it's not pressurizing the unit or not allowing the unit to draft properly. Um, so all air from inside the dwelling, right? If you take up all that combustion air and from inside the dwelling, then two permanent openings installed on the outside will help with that. All right. And we're not going to be calculating louvers, right? Their space, their amount to be able to flow air, but we want to notate if the presence of those louvers or presence of ventilation for those units. Furnace and distributions. All right. So, right, again, while there's three types of drafting, there's also three types of kind of distribution. So you have your upflow, your downflow, and then your horizontal. So your most common units here. So as an inspector, right, you want to describe what type of units you have. All right. So gravity, right? Most of these units work on. Warm air furnaces rely primarily on gravity for circulating the air, heated air. Warm air is lighter than cool air and will rise and move through ducts and pipes. After releasing its heat, the air becomes cooler now, right? And drops back down. Um, and that will go through your return registers to your furnace where it's heated again, and the cycle continues, right? The very earliest types of furnace were gravity type furnaces. Many of these had a blower fan installed to move the heated air, and they had been replaced by modern forced warm air furnaces. Um, Forced warm air furnaces can be identified and described by how the air flows through the heating unit in relation to the warm air outlet and the return air inlet on the furnace. There's three types of forced airs, right? The upflow, the downflow, and the horizontal. We already went over that. On a typical upflow highboy furnace, the warm air outlet is located at the top of the furnace, so warm air is discharged out top. The return air inlet is located at the bottom or the sides of the unit. A cooling unit is usually added to the top of an upflow furnace. Typically, upflow highboy furnaces stand no higher than 6 feet and can occupy 6 square feet of floor space. Upflow lowboys is designed for low clearance areas. Both the warm air outlet and the return air outlet are located at the top of the furnace. The lowboy is usually installed in the basement where most of the ductwork is located above the heating unit. They're usually very compact for like 4 foot crawl spaces. All right, and then you have your downflow units, also referred to as a counterflow as well. You'll hear warm air will discharge out the bottom of the downflow furnace, and the return air inlet is located at the top. The downflow furnace is installed when most of the air duct or pipe distribution systems is located below the furnace. The ducts may be embedded in like the slab, go through the crawl space, or obviously in a basement ceilings. Downflow furnace is similar in dimensions to an upflow. They're pretty much the same size. It's just how they're flowing differently. Their air, how they're pushing it. A lot of times you'll see is the horizontal furnaces too, and that's usually designed to be going crawl spaces, attics. Most of the time you'll see them. Um, and then your gravity warm air furnaces. All right. So gravity warm air furnaces use the facts that warm air is lighter than cold air and warm air rises. In a gravity warm air furnace, warm air may rise through the ducts or pipes. After releasing its heat, the air becomes cooler and heavier. The air drops down the structure through return registers to the furnace where it's heated again. So air is circulated through the house in this manner. All right. There's also a pipeless floor and wall furnaces you may see. All right, so pipeless floor is a gravity warm air heating system that's installed directly beneath the floor. One large grill is installed for the warm air to rise up through. A cool air return is installed for air circulation. This type of furnace is sometimes considered a permanently installed room heater. A wall furnace is installed in the wall and is also considered a permanently installed room heater. Some of these units have blower fans, but most operate on the principle of gravity and airflow. Um, those are more older type of houses. You'll see they're usually located like in the center. Um, and you may see them in the walls, recessed or whatnot. Right? Systems. All right, so here's your warm air heating systems. Here's your distribution system. All right. Um, and then you could see like the high and low returns and all that. The simple description of a warm air heating system is right, you have cool air that enters the furnace, and then the furnace heats up all that air. The warm air begins to rise because warm air rises, and then the air is distributed simply through all the ductwork. Okay, so a very simple, basic unit. The warm air gives off heat and then gets cooler and heavier and returns to the furnace when it's reheated. So then it'll drop back down, pull into the to return and be warmed up again. A gravity warm air system is a furnace which with a means of supplying warm air and return cooling air that relies primarily on gravity to move the air. The system consists of a furnace and some ducts or pipes. Warm air rises and cool air falls. The weight per unit of volume air decreases as it temperature increases. All right. The efficiency of the air circulation in a house with a gravity warm air heating system is going to depend on the difference between the warm air rising and the cool air falling. So the greater the difference, the greater the speed that air will circulate. Also, air circulation in a gravity warm air heating system is greatly affected by air filtering. An air filter can resist and almost block the airflow in a gravity system. You may find that an integral fan has been installed to overcome that. So, you always want to check your air filters. Air filters are one of the things we probably see as all inspectors that always need to be replaced. And um, every 3 months they should be replaced. I always check and make sure that they're clean or dirty or the correct size, and notate that as well in your report. All right. I always like to take a picture of the air filter too and the size, so it's in the report. Just helps clients always know, like, okay, what do I need before I even move in? They can order if it's whatever the size of that filter is. All right. Some disadvantages of the warm air heating systems. Gravity warm air systems have to be centrally located at the lowest level of the structure. Um, they're slow to respond to controls, right? Air movement is slow, and air filtering is obviously restricted. Forced warm air heating systems require blower fans, which sometimes make noise. They're usually loud. The air movement may cause indoor air quality issues because the air agitates dust and other particles, right? Because it's in the basement, usually. Cool air return inlets and warm air supply registers must not be blocked. Because if you restrict any of the air, right, it's going to change the way the unit was designed, and now it's not going to function and circulate as properly. Also, too, you're blocking them with furniture. A lot of people put couches over it. Supply vents. So this is going to dramatically change the comfortability of the efficiency of the unit, and then obviously the comfortability of the home. All right, guys. So we're gonna jump into ducts and distributions. All right. So obviously, you go into a house, and depending on where the unit's located, whether it's in the basement or the ceiling, or the attic, is gonna probably depend on where your ducts are located. All right. And ducts all should be installed based on your manufacturer specific, and that's not something that we're gonna deem as a home inspector. But you always want to take a look at all the ducts, right? If they're in unconditioned spaces, you want to make sure that they're insulated. You want to make sure they're not damaged, that they're, again, Jim talked about in the video of we don't do a flow meter or anything like that. But if you're getting no, you might get heat out of it, but you're not getting any airflow. We do like to notate that in our reports. Obviously to have it evaluated. So you definitely always are checking all your ducts for that. Ducts obviously must be sized properly, okay, for their type of system, size of the unit based on the return flow, all right, so that the unit can work as efficiently and effectively as possible. All right. The maximum discharge temperature, right, coming out of a warm air heating system is 250 degrees. All right. Um, I know I talked about it earlier about the return ducts, right? You want to make sure that it's a sealed return duct. The use of gypsum is allowed, but it needs to be fully gypsum. It can't be wood, with gypsum, right? But when you have gypsum, obviously it's susceptible to moisture. So you want to make sure that there's no moisture damage in there because that obviously leads to fungal growth or mold in your units. So you want to make sure that it's either clean and dry and sealed or obviously a metal unit. So like I said, always take down and take a look at those ductworks and open up those filters and check them out. Um, right? A lot of times they use stud wall cavities, the space between the floor joist and in between the wall, and that you can use that as a plenum too. But again, you get a lot of dust and debris in there that gets behind the filter. All right. So you don't want to use them as air supply, okay, either. Again, because condensation is going to form in there, and then you're going to be blowing out, essentially moldy air if you're not using a sealed proper duct. Um, you never want to use them for like fire resistant assemblies. The plenum and perimeter duct systems, right, and a forced air heating system can be identified by the type of duct system installed. There are two broad, right, systems, a perimeter duct system and then a plenum duct system. Perimeter and plenums, or extended plenum systems are the two duct systems most commonly used at forced warm air heating systems. If you're inspecting a perimeter duct system, you should find supply registers located obviously around the exterior walls of the home, at the floor area. The return registers may be located at the ceiling or inside of a wall, or like the inside of a hallway, like more center of the house. All right. There are two types of the perimeter duct systems, right? You have the perimeter loop, the perimeter radial. A perimeter loop duct system actually has a loop of duct or pipe that connects to all the exterior registers at the perimeter. And then the outside's like all outer edge. The ducts extend out from the centrally located heating system to a loop that connects to all the registers. With a radial perimeter duct system, which is the other one, um, the registers are located. Um, there's no loop in the duct essentially. The perimeter loop air warm heating systems are typically found in homes built on concrete slabs rather than those having a basement. Round ducts are usually sunken into the slab and then distributed throughout. A plenum duct is what more you see with like crawl spaces and basements. They have larger rectangular ducts, and that comes directly out of the heating system. And then they'll usually run the flex ducts and go to different areas of the home, branching out and supplying it to either the walls or the ceilings. Um, Plenum ducts are often called extended plenum duct systems because the large rectangular duct extends directly out of the supply outlet or the main plenum. Like I said, and then obviously you have all your other ductwork that goes about that. So ductwork is usually made of different materials. You'll see sometimes it's just plain steel that's bent, right? Galvanized sheet metal that you'll see, aluminum, copper, fiberglass. They do have some vinyl ones as well that they'll use. And metal ducts are constructed generally though of galvanized is what you'll see. Um, things like aluminum, copper will typically be installed outside because they don't, the galvanized they put inside because of the corrosion. Underdown ducts are made of usually a clay, metal, or a plastic type material. All right. Sometimes you'll even see they put the galvanized in, but they actually start to rust and corrode. When looking at your units, right, you want to check and see if they sometimes they'll be on like vibration isolators, all right. Installed between the metal ducts and the mechanical equipment, you'll see like the black rubber in between the two. And that should be made of a approved material. They used to make them out of asbestos, so you could see that. And sometimes you want to notate that if you see it, but it's possible asbestos material. Um, a big thing we see a lot of times people try to heat up their garages. Ducts that are located in garages or penetrating to the walls of a house, they have to be right to prevent fire or smoke from getting in there. So one, they should either have a fire damper on it if they are supplying air into the garage, and they should also be made out of steel. Okay, a minimum of 26 gauge steel to have some kind of to have a fire rating to prevent carbon monoxide or fire spreading into the house. You never want to have like flex duct running through your garage area. Um, HVAC systems that supply air to the living space of a house must not supply air or return from a garage. So you never want to have your return vent being pulled from the garage. Again, if someone pulls their car in there and it's running, it's going to suck all that carbon monoxide from the house, from the car, and into the house. And obviously, that's not a good thing. Um, and you never really want to have a air handler or a furnace servicing both the garage and the living spaces, right? If there is one, it should be separate. All right, totally independent units because you never want to have the indoor air quality be compromised for the living space. So return air is typically or partially or completely recirculated air. Therefore, it is important to control from where the return air is taken. Um, we're starting to see some newer systems, right? Some ERV systems or so energy recovery systems, and they're pulling fresh air from outside and recirculating that with the return air. But most of the time, your return air is taken from inside the house. All right. Um, And so also too with the return air, you never want to take more return air than the supply air given. All right. Return air must not be taken from also a closet. All right. You don't really want to take it from bathrooms, garages, mechanical rooms, boiler rooms, furnaces, unconditioned spaces too. You never want to take it from like an attic or a crawl space. Should be taken from interior of the home. You want to be circulating the air from the home, not circulating it from outside or some unconditioned areas. All right, so talk about some more ducts again. In a forced warm air heating system, go back to that. The warm air comes out of the furnace in an area called the plenum or the hood. An extended plenum duct system has a large rectangular duct connected to the plenum and extends out in a straight line. The duct between the furnace and the plenum is also called the starting collar. Ducts that carry warm air to a room are called supply ducts. Round or square, you'll see both connected to the branch off the extended ducts are called side takeoffs. Okay. And these are what usually will supply your various rooms. Um, and they're connected to usually your register boots. And changes in ducts are made by angle ducts. You'll see that. A large vertical duct or warm air riser is sometimes called a stack duct. All right. A warm air duct that runs horizontally from the furnace plenum to a riser is called a leader. Dampers may be installed. All right. And that will control the flow and air to different rooms. So sometimes there'll be an electronic damper and you'll see a box on the main trunk of the ductwork, right? And that might be to split for floors or different sides of the house. All right. And then sometimes you'll see manual dampers and they'll use them sometimes in the summer or winter months, depending on if you didn't want cold air to go, say, in the summer months into your bathrooms. All right. A damper is right. It is gonna alter that air for the areas. All right. So just be mindful of that if they're turning air off into half the house. you might want to note that or show that to your clients, like, hey, there's a damper here that's turned off. So I always like to note that if it's if I do see it in my reports, so that people understand and why, not why they're off, but where they are located and how they and what they're servicing. Um, there's also, right, so there's three general outlet devices you want to call them. So grills, registers, diffusers. That's all the name for what's pushing the air out into your rooms. Okay, so you hear those different things. But grills, right, deflect the air up and down, side to side, depending on the direction that the louvers are pointed. Grills are installed high or low on walls. You'll see them. Floor grills are common too as well. Registers are similar to grills, but registers have dampers to control, so that's when you can push them on and off. All right. And they can be located floors or walls as well. Diffusers are typically formed in concentric cones or pyramids. And they can be located on the walls, usually found on ceilings. Baseboard diffusers are used in perimeter forced heating systems as well. All right, back on the gas furnaces. BTU, which is the British Thermal Unit. And that's the essentially the capacity of the output of your unit. So sometimes you'll find that information on there, right, on the data tag, the BTUs. But again, we're not there to say whether it's a sufficient BTUs or not. Okay. Um, and then there's also the AFU E, and that's the furnace is identified as their efficiency. So you'll see usually in a percentage how efficient the unit is, whether it could be 90%, 98%. And it's all going to vary between that. Again, it's not something that we are commenting on or providing more information on it, but it's sometimes the clients will ask, and at least you could see it on the unit itself. It's usually on a big yellow sticker plastered on there. All right, so the BTU is a unit of energy. So approximately 1 pound of heat of water by 1 degree Fahrenheit. So 1 cubic foot of natural gas contains about 1,000 BTUs. And a gas furnace that fires at a rate of 100,000 BTUs per hour will burn, simple math, 100 cubic feet of gas every hour. All right. And again, there's going to be a data plate on your tag, and it'll have all that information, and for your client. So I always take a picture of it and put it in the report. You don't have to, but it is nice to send them with that. Um, a gas furnace also could be identified by the type of ignitions, right? So you can have a standing pilot, an intermittent pilot, or a direct spark or a hot surface ignition. Older gas furnaces have a standing pilot that is always burning. So you'll see that whether the unit's running or not, you'll look through a little pilot light and you'll see a little flame flickering. Modern furnaces are getting away from that because it's always burning some gas, right? So now they go into like an electronic ignition so that once it fires up, it'll fire the pilot light and light that unit. Um, but they still use standard standing pilot lights today. Okay. Um, and it's a main characteristic of a low efficiency furnace. Okay. So a mid-efficiency furnace is equipped with a naturally aspirating gas burner and a pilot light. The pilot light is unlike a standing light, it doesn't run continuously. So it'll shut off when the furnace is not in operation, when the thermostat is not calling for any heat. The heat exchanger is more efficient than the one inside a conventional furnace. There's no draft hood. There may be a small fan installed in the furnace. In the flue pipe, excuse me, to create an induced draft. So these furnaces are often referred to as induced draft furnaces. Um, it's also equipped with automatic controls, blower and a motor assembly, venting and air filtering. Some mid-efficiency furnaces have a motorized damper installed in the flue vent, and that'll help get the unit started. All right, a mid furnace is about 20% more efficient than a conventional. All right. And then a high efficiency furnace, right, as a solid state control board controls the ignition. There's no continuous pilot light. So once that pilot light lights, it goes off. There are two or sometimes three heat exchangers installed in these units. Condensates are produced when the heat is extracted. And that's what makes them essentially way more efficient because they're using almost all the heat that the gas is providing. And that's when you'll see the PVC pipes or the CPVC pipes as vent and exhaust pipes. There's no need to obviously go up a chimney. There are two different types of high efficiency furnaces, one with an intermittent pilot or a direct spark, and one with a hot surface ignition. Um, and the production of condensate is the main distinguishing difference between a high efficiency and a mid and obviously a standing pilot light. Um, so intermittent pilot furnaces, right? When the thermostat on a furnace that is an intermittent pilot calls for heat, there's a short ignition period when a high voltage spark is generated. The spark ignites the pilot. When the lighting the pilot flame, the flame must be confirmed through a flame confirmation process. So there's usually like some kind of sensor in there. All right. That will realize that the flame is good. The burners continue to burn until the thermostat is satisfied at this temperature, and then it'll shut everything down. The hot surface ignition furnace typically has two or more heat exchangers. There's no pilot light. Instead, there's an electronic ignition device. This device is often called a glow plug or a glow stick, and it starts the gas burner. When the thermostat calls for heat, a purge cycle starts with the draft fan activating, so it'll push that air out, and then the igniter lights up to a very high, like hot temperature. The gas valve opens up, and the gas will flow to the burner, and it ignites. And then a sensor will confirm, okay, gas flame is on, burner nozzle at the burner nozzle, and then the electric power to the igniter turns off. All right, so with your unit, you always have obviously your thermostat, the heat exchanger. There's things called the thermocoupler pile. There's the other regulators and control switches. So we'll go through all that now. All right. So obviously the thermostat, everybody is familiar with, usually located on a hallway in a room, and you operate it up, down, twist it, heat, cold. And that's what's going to get your ambient air temperature that's in the room, and then you can change it to your desired temperature. The heat exchanger is a metal, right, fins essentially, and that's located in between the combustion gases and the air that's circulating through the furnace. And the hot combustion gases heat up the metal material of the heat exchanger, and the heat is transferred from the hot metal to the air that's passing through it. All right. And then the warm air is obviously forced out and in through the ducts and into your home. All right. A thermocouple is a device that senses the heat. So it's used in gas furnaces that have a standing pilot light. And it's going to determine whether the pilot flame is lit before the main gas valve is open to supply gas to the burners. All right. So once it senses that, it opens up the gas burners and everything ignites. The heat of the pilot flame is then converted to electricity by the thermocouple. It turns heat into electric current. The current is strong enough to open the main gas valve after being operated, and the gas flows through the pilot light. If the thermocouple does not detect the pilot flame, it will just turn off the gas supply all in all, and that's there to just essentially help protect the unit. The thermal pile is used on some standing pilot flames. The thermal pile will sense the heat from a pilot light flame. It is larger than a thermocouple usually, and it operates both the gas valve and the pilot light itself. If there's a thermal pile present, there's no transformer required. There's also something called a mercury flame sensor. It may be used in electronic ignition units. It consists of a sensor filled with mercury and a capillary tube. Um, and it just heats up the sensor there. All right. Then you also have the gas pressure regulator, and that's installed right on the gas valve itself. And that'll just regulate the pressure that's coming into that unit. It wants to make sure you have a constant pressure in the burner manifold. In propane gas systems, the the regulator is going to be located between the supply tank and the main gas valve. All right. And then there's also a fan limit switch, which is another safety device that's installed inside the furnace plenum, which it senses the air temperature that passes through that area. It controls the operation of the furnace within a temperature range, usually between 80 degrees and 150. And it's going to prevent it from essentially overheating the burner assembly. Okay. You can also turn off the fan when the burner has been turned off and the temperature drops below the lowest setting. All right, so the operation of your unit, the flames come from the burners and go into an enclosure called the combustion chamber or the firebox. All right, and then the heat exchanger is located directly above that. So essentially, heat exchanger up here, and then here's your combustion chamber down here. Um, the heat from the combustion process place is transferred to those metal heat exchangers. All right, heat passes through all that, and then again, the heat exchanger can reach several hundred degrees in temperature. Air flowing across the heat exchanger must travel at a high speed and must be uniform across all sections of the exchanger. If the airflow is low across one section, that section of the exchanger will overheat and could cause failure. So it has to be evenly distributed throughout. Again, it's not something that we're going to be able to tell, but this is just so you guys can understand how that unit kind of works. There are sections of the heat exchanger called cells. There's one cell for each burner, and the burner is located directly below the exchanger cell. The heat moves up from the burner through the cell. At the top of the heat exchanger, a manifold combines all of the open cells into one collection device. The manifold collects the exhaust gases coming up and out of the cell and directs the gases into the exhaust outlet. The vent connector pipe or the metal flue pipe is connected to an outlet. The exhaust gases vent through this pipe to the outside. Um, and then the exhaust gases also will heat up the exchanger at a very high temperature. Air from the house's interior will pass through the exchanger, all right, again, from the return plenum, and then it's transferred to that air, right, the heat, and then it'll exit between 70 and 140 degrees of temperature, all right? Um, a temperature rise above 70 degrees to 110 is acceptable. Um, the heat exchanger should not be covered, obviously, with any soot, carbon deposits, or debris. That's going to reduce the efficiency. Dirty heat exchangers should be cleaned, obviously, by a qualified professional. So when you guys are looking at your units, open them up, take a look at all those burners. You'll see them in there. If there's any, again, dust buildup in there, soot, that's what's a black, residue covering them. You want to notate that as obviously having the system cleaned and serviced. Another thing you want to check, right, is when the gas pipe comes through that unit, it should be a hard pipe. You don't want to use flex pipe through that unit. All right, so you want to definitely use a hard pipe. That's in our jurisdiction. I don't know if it's different in other ones, but I know in New York, that's required. Also, too, another big thing that we find all the time is the electrical wire coming through your furnace. All right, you want to make sure it has a proper bushing, the low voltage wires, the electrical wire, because a lot of times we'll see is that electrical wire is rubbing up against that unit every time it turns on and off. It's vibrating and it damages the electric wire going into it. And now you have an open electrical connection inside a furnace that obviously has gas in it. It doesn't really mix well. So it's just some other things that you guys can look at when you open up those units and you're taking a look at the burners, the heat exchangers, the data plates, look for other obviously issues with that. All right, so back on primary and secondary air. So gas burners combine the proper mixture of air and gas from the combustion process. All right, both primary and secondary air are required. All right, primary air is that which mixes the gases before going into the burners, and secondary air is what's around the flame for proper combustion. Secondary air flow around the burners and heat exchanger. And it mixes the unburned gases in the heat exchanger, and then the secondary air is drawn into the burner by the draft. Um, you also might find crossover igniters. Many gas furnaces have individual chambers or sections of the heat exchanger. Inside each section is a flame burner to prevent unburned gases from entering the combustion chamber. All burners should fire up almost the same time. This simultaneously ignition can be provided by a gas burner component called a crossover or crossover igniter. All right, so if you see only like one or two burners are igniting, obviously there's something wrong with that unit. Or if you see like one or two are really blue and then others are red, again, that unit most likely needs to be serviced. Something is going on with those chambers. All right. There are two broad categories of gas burners. One's a monoport, the other's a multi-port. All right. And they're installed in the forced draft and not in a natural draft. The monoport burners are common with high efficiency furnaces, and they can fire operate in any direction or orientation. Okay, so you can have them up, down, horizontal, all that good stuff. Um, Right, we talked about the flames, right? You can see these are like orange and yellow in these colors, but you really want to have a nice blue, even flame in your unit. So, I always let the unit fire up and run for at least 30 seconds to a minute before I actually go and look at the flames because I want to make sure, one, that it's all running, it's continuously running, and that those flames are a good, nice blue color. Um, it also shouldn't be moving around the flame. It should just be kind of in one continuous like motion. All right. You never want to see the flame going up or down or erratic because that means there's some kind of drafting issue. Um, and then if you see any yellow on the tips or anything like that, it could be inadequate airflow inadequate secondary air. All right. So again, you want to look and make sure you're just finding that nice blue look. The burners too, you want to make sure you don't see any burn marks on them or anything like that. Um, all right. Also, two cracks. All right. In the heat exchanger, you want to make sure there's no cracks in them. Okay. Especially when you turn them first on, that's when you'll notice it because you'll see the gas or maybe a flame go out in another direction. All right. The blower fan, obviously that's going to be in the bottom part. So that's going to, fan has, right, it has two functions, the blower fan. It moves the heated air through the distribution supply ducts or pipes, and it protects the heat exchanger from overheating. Because if the fan went dead, the flames would just be overheating that. It wouldn't be able to push the air across it. So it serves as both purposes. All right. Usually the fan will kick on first, okay, and get everything moving, and then it'll ignite. Typically they're belt or direct driven. Direct drives have various fan speeds that can be set or adjusted by the wiring. Belt-driven motors can be adjusted physically, usually. Again, it's not something we're doing or even commenting on, but just so you guys know that there is variable speeds on those. So sometimes if you're finding a house is set low and all the vents are low, it could just be that that's what the setting is. All right. So another thing too, when you open up your burner cabinets, right, you want to make sure there's no rust or damage, especially on the bottom of the unit, right? If there's any condensation happening, that's typically what it's from. All right. Any dirt, soot, check the filters. And these units all should be properly maintained, right? We recommend that our clients have these serviced annually and also serviced, when you take ownership of these units. Even in new construction, a lot of guys, just because it's new doesn't mean that it's perfect. New construction, I always highly recommend they have them cleaned and serviced because the amount of construction debris and dust that is in those units will certainly lead to a less efficient unit. Sheetrock dust is everywhere, so you definitely want to make sure that you have these units serviced and talk to your clients about that. All right, venting. So 6 basic ways to vent. All right. So you always want to look at the chimney vent connections, right? Make sure that everything looks in good shape, that they're properly pitched. All right. And then the 6 really ways, right? You go through a masonry chimney. You can have a type B vent, which is the galvanized metal or a single wall metal one. Um, you can vent it to the wall, you can vent it through PVC piping or CPVC, you can vent it through the sidewalls or the roof. So masonry chimneys, we see a lot of masonry chimneys here in the Northeast. They should have a flue liner, that's installed. Okay, so a masonry chimney without a metal flue liner, the byproducts of the gas will actually like deteriorate that unit, and that could lead to harmful gases getting back in the house. So anytime we see houses that went from oil to gas, we're always looking to make sure that they properly line the chimney. All right. Many chimneys are made of metal. We see a lot of like metal clad chimneys and metal flue vents, which is common too. All right. If there's an old conventional one, like we said, we look for that. Um, Yeah, and the other thing too, when you have a high efficiency furnaces, the temperatures coming out of those units are lower temperatures, right, than the old conventional units. So what happens is if you're venting it into a chimney, the gases may not be able to get up those chimneys. They're not designed to lift that much heat because the air. So then it becomes buoyant. It comes back down the chimney, and that's when you get improper drafting. So a lot of times we look for, you never want to have a water heater venting into a chimney by itself, an old conventional chimney, or a high efficiency furnace. Okay, so they really should be vented separately or additionally. So we will note that if we do see it. All right, we do see it a lot, especially online chimneys. A lot of guys, like I said, go from oil and don't upgrade the liner with when they upgrade to gas units. All right. So a chimney provides a draft, right? So we're talking about that. The vent, and that means to vent the combustion byproducts of the furnace. A good chimney draft is not necessary for the combustion process in a furnace, but it's essential for the venting. So without drafting, this unit's still going to run and be effective, but venting it is that's where it becomes the issue. All right. So again, your different type of chimneys, right? Your type A, low heat, prefabricated metal chimneys. And usually they have to be, or they have to be approved by the UL, the underwriter's laboratory. Type B vents, right, are UL listed, and they're recommended for your standard gas firing systems with draft hoods and are category one appliances. The BW vents are for wall furnaces, okay? There's type C vents, are typically used for your standard gas fired furnaces and installed in attic spaces. L vents are for appliances listed for the use with type L or type B vents. Um, all right. And then obviously you have your high efficiency, your PVC vents for your furnacing. All right. So usually you see the PVC extending from the furnace through the wall to the outside. Could also vent through the roof as well. A PVC vent will likely indicate a high efficiency unit. The pipe is typically 2 inches in diameter, and there's usually two. All right. So Jim showed us that in the unit. One faces down, and then obviously one is separate from that. Um, there's typically they typically slope, all right, as well, and you want it a quarter of an inch per linear foot is recommended, and it should be supported adequately. All right, a lot of times you see them not supported and sagging, and then that's going to allow the condensation to pool. So if you have sagging in there, and what's going to happen is, it's not going to drain the water out of there, and then you could get obviously a poor drafting as well. All right, so the flue pipe, right, is the passage which the gases from the combustion chamber of the heating system move to the outside of your home. A flue is also referred to as a flue pipe, a vent pipe, or a vent connector. A chimney flue is the flue that is inside a chimney, and the flue from the heating system to the chimney is often called the vent connector, chimney connector, or smoke pipe. A flue outlet or vent is in the opening heating system which the gases move, through. We always look too to make sure the connection of the chimney flue. So if you have a galvanized flue running into a chimney, a lot of times they put what's called like chimney cement on there, and a lot of times you'll see it crack or even it'll separate from the chimney. So you want to make sure that that connection is there. Again, poor drafting, you may get carbon monoxide flowing back into the unit. So I always recommend having that sealed or resealed. Again, I always have my carbon monoxide meter on me, so I'll always like put it around that unit to see, especially while the unit's running when it turns off and on to make sure that nothing's drafting back in. Um, so the flue pipe obviously connects the heating system to the chimney, and it should not extend any further than the inner liner surface of the chimney flue. The flue pipe of the heating system for the furnace or the boiler should not be sharing the same chimney as a conventional fireplace. And you never want to vent a chimney with two different heating sources, right? So if you have an oil boiler and a gas water heater, you never want to share those, right? Because now you have two different combustion products, two different heat temperatures, right? And it's not going to flow and draft properly. So again, that's something you want to comment on if you see that. We actually ran into that today. We had an old house. They upgraded to gas water heater, left the old oil-fired boiler in there, and again, it was drafting all into the same chimney. All right. Especially you never want to draft into one that has a wood burner. Okay, again, because there's an opening at the wood burning fireplace, so it can allow for gases to drop back into that damper, which obviously can be combustible or harmful into the home. All right. So a draft hood, all right, is usually installed, and that is your draft diverter or vent connector, right? You can see, and right is installed on a standing pilot gas furnaces. Mid and high efficiency gas furnaces do not have draft hoods. Draft hoods are attached to the top of the furnace above the flue outlet, and it's sometimes called a diverter. The draft hoods produce a constant low draft of air for the combustion chamber. It allows dilution of the air to be drawn into the vent pipe, and it helps cool the exhaust and ensures a better draft, essentially. You want to make sure when you look at those draft hoods that they're not damaged, and rusted or corroded. Um, and those could be internal or external of the unit, so you'll see them sometimes. Most conventional gas furnaces will have a heat shield, and that will prevent flame rollout. All right. It contains the flame inside the burner chamber. It also protects the burner against strong drafts. All right, so here's another video, and this is determining the age of your units. So I'll just play the video and then we'll go over it.
Commissioner unit. There's a line going up, the refrigerant lines, suction line, liquid line, go up into the attic. Go up into the attic. Here's the air conditioner unit. There's a line going up, the refrigerant lines, suction line, liquid line, go up into the attic. They make it look like a downspout. That's nice. But there's the air conditioner. So it was installed after the house was built. Shut off switch. It's a Kenmore. And I wanted to show you a cool thing. Somebody asked me, how do I age a unit? And I'm not sure if you know this one. There's a little trick. Go to www.buildingcenter.org. Buildingcenter.org. And you click this button for HVAC equipment. They have one for heaters as well. And you look up the manufacturer, and this one is Kenmore. And let's go back to the image. So here's my serial number for the unit, L970627870. And it's this style for Kenmore. I have my L, right? It's not an H or the other ones. So right here, it tells you if it's this style, then the first 2 years, first two numbers is the year, and the second two is the week. So over here, the serial number on the air conditioner of the Kenmore on the property I'm inspecting was manufactured in 1997. That's an easy way to age the unit if you're interested in doing that. You're not required to.
All right, so yeah, Ben went over finding your data tag. I always recommend, and I always do in my reports, is take a picture of the data tag, right? So you know the information that's on that tag. And there's a lot of great information on that for you to know. So, but not required. All right. And buildingcenter.org, if you guys aren't using it, you definitely should check it out. You go to that. Most of the manufacturers are on there. Some manufacturers aren't. And they recommend that you reach out to obviously the manufacturer, for that information. But sometimes it's kind of tough because they don't get back to you right away. But yeah, there's definitely a lot of good information, and highly recommend taking a picture of that because it'll give you information too, like the breaker size, what type of refrigerant it is in the units, and something you definitely want to, make your client aware of how old your units are. All right, so we've been talking a lot about gas furnaces. Now we're going to jump into oil furnaces. All right. So a conventional oil furnace, right? Most conventional oil furnaces in homes today are conventional. They're not high efficiency, right? Condensing heating systems. These conventional furnaces are slowly being replaced, right? They're just outdated, and they don't make them in high efficiency systems. If you're inspecting a conventional oil furnace with a cast iron burner, it's likely has an AFU, which is like the seasonal efficiency rating of 60%, which is a very low efficient heating system. Um, the general steps of the heating cycle for a conventional oil furnace, obviously thermostat. So you turn that thermostat on, it's going to call for heat, and it's going to close an electrical circuit and a relay. That's going to fire up your oil burner, transformer, and the fuel pump. Um, the motor on the fuel pump sucks the fuel in, supplies from the tank, and pushes into the burner nozzle. And at that nozzle, it atomizes the fuel and sends it into the blower and the combustion air into the chamber. And then it sends a high voltage strike and fires up and atomizes the fuel and air and ignited. They're usually generally loud and by the burner, and that signals that the unit is running. There's a safety device in the operation when the burner is shooting flames. Then it's usually a photo cell referred to as a CAD cell, and it looks for a flame and confirms that it exists. It can detect a flame located in the combustion chamber, and if it does that, within a few seconds, the circuit to the burner is opened and the burner is shut down. Some oil furnaces don't have a CAD cell and instead have a stack relay, and that senses heat instead of light. If the stack relay does not sense heat, the circuit to the burner shuts it down. All right, so those are just ways that it protects it. Again, it's not really something that you're looking for or identifying, but might be something that obviously is an issue with the burner. The energy efficiency of an oil furnace is measured by its annual fuel utilization, right? The AFUE. The higher the number, the higher efficiency. Um, and then those ratings will generally change, minimums for those ratings. So I don't really go too much into them with my clients, but it is something they generally will ask for. A typical non-condensing mid-efficiency oil furnace uses less oil than a conventional furnace. Obviously, they're non-condensing units. A burner shoots flames and heat into a combustion chamber. The chamber is usually made up of some type of heat-resistant ceramic material. Combustion air is drawn into the burner by a fan where it mixes with the oil. The gun ignites the oil-air mixture, flames shoot into the chamber, and passes through the heat exchanger just like in a gas furnace, and then vented to the outside. The blower fan pushes all the hot air out and through the heat exchanger, and then the heat's transferred through the metal of the heat exchanger, and you got hot air. All right. Um, and then a typical high efficiency condensing furnace has the two heat exchangers, just like in the gas fired unit. The heat exchanger is designed to extract most of the heat again, and then the second heat exchanger extracts the rest of the heat, and that is then turned into water vapor and then put into condensation, and then it's vented through a PVC pipe and installed through a sidewall of the building. Oil furnaces, very much similar to gas furnaces. You'll have the heat exchanger, the burner. They'll have a little bit different things in the fuel pump, the motor. Obviously, there's an oil tank. There won't be a gas meter. The blower, a motor, combustion blower. There's usually a clean out or an observation port. And then obviously a vent opening and air filtering. filtering. So a lot of times with the vents, you'll see that there'll be a little a hole in them, all right, probably about a diameter of like a pencil. And that's a probe, all right, in the low efficiency furnaces. You'll see that, and they use that for testing essentially. It's fine to have it left open. It doesn't need to be sealed. A lot of times people don't realize that ask that question, what's that for? And that's just really for, calibrating the unit. Again, it's not something we do or deal with, but if you don't regularly see oil furnaces, that's just something you will notice that's different from a gas furnace. Um, Again, the furnace controls, thermostat, the only difference is you have a CAD cell or a fan control, or as like a solenoid, and that will detect the heat on like a thermocouple or a thermopile in a gas furnace unit. Um, the CAD cell again is that safety device that we talked about. All right, and those all safety features will work the same in a oil fire furnace as they do in a gas style furnace. All right. So the same thing. If there's too much heat, it'll turn it down. If there's not enough heat, again, it'll turn those units down to help protect them. Um, and again, the combustion chamber is where all the gases and where the combustion takes place inside the lower part of the heat exchanger. The combustion chamber is made of a material that can stand very high temperatures, and the combustion chambers can be made of either stainless steel, a lot of times cast iron, or a refractory type material such as a fire brick or cement clay. And the nozzle of the burner gun assembly sticks into that chamber area. Most chambers are round, but some can be found to be square or octagon. Some modern oil furnaces have sealed combustion chambers, and they just help with efficiency. Okay, similar as a gas one. All right, so okay, so oil burners, right? Most common oil burner that you'll see is the atomizing oil burner, sometimes called a gun type burner. There's some special burners called vaporizing or pot type burners. There are very few parts to atomizing oil. So there's usually like a little red button that you can reset on there. You'll see that's on like the head assembly of the pump. Um, the ignition or the transformer. There'll be the cell for the CAD cell for the protection, obviously the gun, the nozzle, and the electrode. So it's a very simple system, similar to the gas as well. All right, and then everything obviously goes into that. It fires up and goes into the combustion chamber and heats up. An atomizing burner uses an electrical pump and a nozzle that atomizes the oil, and that means it just breaks down the liquid and sprays it into those fine droplets, and that just helps with efficiency. And that mixes with the air. The burner combines fuel oil with air and mixes them together. It delivers the fuel mixture to the gun and ignites it. The oil pump provides oil, and it sucks it from the oil storage tank and it sends it to the gun. The pump delivers the oil under pressure, usually between 75 and like 120 psi's. The pump is usually mounted on the side of the burner assembly. Okay. The barrel of the gun is a steel tube about 3 inches in diameter and about 1 foot in length. The electrodes are at the end of that tube. Um, the electrodes, right? That's what behaves as like a spark or an ignition source. All right. And usually a high voltage, and they spark when the oil sprays. Once the flame is confirmed, the spark shuts off and the flame continues. All right. And the combustion inside the fire and refractory panel chamber continues. All right. These are usually hooked up to 120 volts. All right. There's usually not a transformer. Most oil fire burners will have a flame like a blowtorch, with a long ragged flame. The flame is usually orange and yellow in color, not like in gas when you see that nice blue color. They usually have the yellow tips. There may be some gray or black smoke above the flame. There shouldn't be any like bright colors or large sparks. It should be a nice like even kind of flame like that. That's orange and yellow. The modern gas, though, a lot more high efficiency units will have more of a blue colored flame core and a tight more of a tight flame than in your traditional burner type. Um, the main blower circulating fan, right, will circulate through the furnace and pushes the heated air through the distribution ducts, same as in a gas furnace. Okay. Again, they could be variable drives, and newer furnaces will have variable speeds. Excuse me. Um, Combustion air blower fans. They will have high efficiency ones. You will see observation ports, same as in or gas. They'll have little observation ports you can look through. You'll see like a little metal ring sometimes that you can open and close. All right. Oil furnaces vent the same way that gases furnaces do. High efficiency oil furnaces can use PVC piping to vent the combustion byproducts and gases through a sidewall. But generally, you'll see a metal flue pipe. That's more what I would see, typically out in the field, and they're usually venting through a chimney. You want to have that vented upwards, right? You want to have a proper pitch on it, so at least 1/4 of an inch per linear foot. Ideally, the furnace should not be more than a 10-foot pipe diameter from the chimney connection. Um, Appropriate clearances obviously want to be maintained. You don't want it in contact with any wood, sheetrock, or insulation. All right, so that's always something you want to check for too. Especially the standard flue pipe metal material. There's also going to be on an oil fired unit, which you won't see on a gas, is what's called a barometric damper. All right, and it's often called a draft regulator. Um, and it just allows for proper ventilation. So when you fire up that unit, it'll open up to allow for the air to come up into the unit. And it's similar to a draft hood, but it just looks a little different. Dampers or regulators are recommended for all of your oil furnaces. So if you don't see a damper or a barometric damper or draft regulator, you should note that because it's not going to properly draft. Okay. Um, and that damper should be located as close to the unit as possible, right? You don't want it all the way up on the chimney side. It should be as close to the chamber as possible. Jumping back into it, now we're talking about storage and fuel storage, okay? So when you have an oil tank, I always like to comment where the oil fill is, right? Where the unit's located, and then where what type of tank it is, okay? So is the tank installed above grade or below grade? I always like to take a look at to make sure, is there oil in the tank, right? Because we get there and there's no oil in the tank, we're not going to be able to test and run those units. So we can let the listing agent know, and the clients, obviously. All right. So fuel tank typically installed, in a metal tank, could be a fiberglass tank. They also make now the stainless steel tanks with the with the liner in them. Generally, they're about 275 gallons tanks. You'll find, all right, and they could be installed above or below grade, or they can be installed in the ground. Which again, you want to comment on that as well if you find it. If the unit is installed above grade, there'll usually be one line that leads to the unit, okay, and then the vent pipe will be upstairs with the fill pipe. When you have it below grade, right, the vent pipe and the fill pipe need to come above grade so that the unit can vent, obviously, and be filled up as well. All right. There also should be a shutoff valve located on the fuel storage unit, and there also should be a oil filter there as well. Okay, because obviously contaminants from inside the tank or things like that, you want to be able to change that yearly to help protect the pump from clogging. All right, so high efficiency heat exchangers. Okay, so here's a picture of one of them. They use the same principles that hot gases. They release a lot of energy. They change their state from gas to a liquid. So there's a lot of condensation in them. We can cool that vapor inside a furnace using the heat exchangers. High efficiency furnaces, again, will have, same as gas units, two heat exchangers. All right. The condensation will take place in the second or that third heat exchanger. And that's why they're usually made of stainless steel because it's more resistant to any corrosion or rusting. And then the first heat exchanger is typically made of a conventional like galvanized steel because again, they don't have that condensation. Um, and then that's when you'll see with the high efficiency again that there is a condensate pump. Okay. Um, a quart of condensation water actually may drain out every 30 minutes. So it's a lot of water that when those units are running for a prolonged time will condense out of those units. All right. Um, so coal, wood, multi-fuel furnaces, we don't, I would say see that as common. Coal was a much bigger thing back in the day. But they're usually, hand fired. They could be, or fired with a stoker. Coal has to be brought from the storage to the furnace either by hand or automatically with a mechanism that feeds it. All right. A lot of coals were just gravity units. Now they have, blower fans. Again, not a very common heat source, especially here where I am. With that, obviously you don't want to block any access. You want to have proper adequate access. Coal is very dirty. There has to be an ash pit door to run the furnace and clean it. There's similar to anything else. There's a cabinet. There's a firebox. There's a grate for the coal to land on. There's a heat exchanger. There's a blower, a fan, a motor. There's also an access door for stoking and cleaning. They usually have a small blower fan to the fire, and then if there's any automatic controls there. A wood furnace, right? Very similar to a coal furnace, except that it burns wood instead. The components and accessories of those units are all very similar. Okay. Anytime you're looking at a fireplace, or excuse me, a coal or wood burning unit, you want to obviously identify what is the heating source, and then if the unit is functional. Okay. Um, Sometimes you'll find that they can take both, right? Multi-fueled furnace. And you can do them together. Again, you can uh, comment on the type of that. But these units should be obviously cleaned on a regular basis. And we want to just really check the vent pipe, the heat exchanger on there, the outside of it, the furnace, make sure all the access doors are sealed and tight, that none are rusted or damaged. Make sure the air filter is in clean and in good working. And then obviously that there's no ash or debris that's blocking any of that unit, or that it needs to be serviced. All right, hydronic heating systems, which is again, up here in the Northeast, very common. You have a burner, a boiler in the basement. It could be heat, it could be oil fired, it could be propane fired, and that is going to heat your water. Okay, and there's obviously your series, a loop system. There could be a two-pipe system that has a direct return, or you can have a one-pipe system that just runs in a loop. So it's forcing instead of air, it's using water to feed into the radiators. Okay. And then the cold air will warm up when it hits the bottom of those radiators and they're hot, and it'll push the air through the room and heat it. So the water circulates in the system by gravity flow. All right. Radiators or baseboards are usually located within rooms and hallways on the outside of the rooms, along the exterior of the walls. There may be radiant panels in the floor or the ceiling, so we'll see radiant floors, or you can even see it in the ceiling. There may be one or more thermostats installed in the house. When the thermostat calls for heat, the boiler will fire up, obviously, and then send hot water to those systems. All right. Um, so again, when you're identifying those units, right, you want to identify the type of unit it is. I like to take a picture of the data plate, the age, right? Is it circulating water or steam? All right. And then you want to look at obviously how everything in the condition of it is, rust, things like that. I like to use it. I have a flare gun, so we test all the radiators and temperatures to make sure that they're all evenly flowing and heating up properly. All right. We'll run the heat system all year long, 365, and we'll test all those units. All right. I always also like to take a picture of everyone and put it in my report to show that everything was functional at the time of the inspection. All right. Every hot water heating system circulates water either by a pump or a forced hot water heating system or by gravity. All right. The distribution pipes could be made of different type of materials. So it could be cast iron, galvanized. We see a lot of copper. And then obviously now they're using a lot of PEX, right? Systems. All right. Sorry. The one pipe systems, right? There's going to be a single pipe that's going to carry the hot water throughout the system. All right. And that single pipe will run to the radiators and it also carries the cool water back to the boiler. Okay. So that's a one pipe system. Then there's a series loop type system. All right. Which each heat emitting unit, so each radiator or baseboard, is part of a loop. So when you shut off one unit, then the entire flow or water is stopped. The water travels from the heating system, flows through each heat emitting unit, and returns to the heating system, all in one continuous loop. There's no pipes or branches. All the heating units are connected one after the other in a series. Um, and then there's the two-pipe direct return system. So in a two-pipe direct return system, hot water is going to return to the system boiler or water heater directly from each unit. So it does not pass through other units. So it'll go through the baseboard or the radiator. It'll heat that unit and it'll go directly back to the burner to get heated back up and then send back over to that unit. Um, so each unit's separate. All right. And then you can have a combination of these units. That's not very common. I don't really see that much in those units. All right. Um, so you'll see a lot of hydronic heating systems throughout. All right. They can be controlled by either zone valves or they can be controlled by circulators. So those are kind of your two things. So zoning is achieved by installing a valve and a thermostat. So if you have a zone, typically you'll have one thermostat and one zone valve. If you have two zones, you'll have two thermostats, two zone valves. That's how that'll work. And that thermostat will activate that zone and tell the hot water to go to zone one or go to zone two, whichever it is attached to. Um, and that helps like balance the system. So typically you'll see it per floor. Sometimes you'll see it for the bedrooms and then the living spaces. So that's how that you can break that down. There's also radiant panels installed on the hot water heating system. It's not considered a radiator nor baseboard, but the pipes are concealed in the floor, ceiling, or water. So, radiant floor heat, you'll run that. Again, there'll usually be a separate thermostat. The downside to the radiant heat, because it has long sloping lines, a lot of times it's hundreds of feet versus your baseboard. It takes a lot of time to heat up and get going. So if you do find that you have hot water baseboard, radiant floor heat or ceilings, you do want to fire that up in the beginning of your inspection so that by the time you end your inspection, you can test that and see that it's working. All right, so boilers. Hot water boilers, you may inspect be made of cast iron, which is probably the most common, or steel. Cast iron, right? It has good resistance, corrosive properties. It's a lot more heavy duty, and it's resistant. It's better has better heat transfer. Um, all right, gravity hot water heater systems. You might find a gravity hot water heater system installed in an old home. You can identify a gravity system by its large diameter pipes made of either wrought iron or black iron. They're very large pipes to supply the hot water to the rooms and spaces in the building. The boiler of a gravity hot water heater system will likely be made of cast iron. Those units are usually very large. Again, it's generally an older home thing. The main method by which the water moves in a gravity hot water, the difference in weight of the water at different temperatures, and the hot water will float and the cold water will fall. Again, not very common anymore to see those. All right. Um, so because water expands when heated, you really want to make sure that each heating system has an expansion tank on it. Okay. So because again, the hot water, your boiler turns on, it heats up, the water expands, it cools down, it condenses. So, the expansion tank will allow for that expansion and contraction. All right. So I always take a look and make sure one that there's a presence of an expansion tank. And then what I do too is I go a step further. I always flick the expansion tank. If you flick it on the one side, it's going to sound like a thud because there's water in it. On the other side, it should be empty. It should have air in it. So if you hear it like a dink dink, because it's empty, you know that it's working, right? If you hit it and it's solid on both ends of the expansion tank, you'll know that that expansion tank is bad. And again, it's something you could tell your clients like, hey, this expansion tank is bad. It's probably filled with water. It's not allowing that expansion and contraction. It probably needs to be replaced. Also make sure that the expansion tanks are properly supported. A lot of times guys will hang them on their side, and what happens is then they fill with water. Water is 8 pounds per gallon. So if the tank, say, is a 3-gallon tank, it may only have half a gallon of water in it normally. But then if it breaks, now it's filled with 3 gallons. You just multiplied it by three. So there's a lot of extra weight, puts a lot of weight on that connection and could cause a leak or break off. So always comment, make sure that they're adequately supported to the either the joist or to something. Um, Forced hot water heating systems, right? The most commonly used method for forcing hot water to circulate in the system are by pumps or by combination of pumps, local boosters. There's other ways by forcing water to circulate in a hot water heating system, but they are not as common. They include the use of nipples on each radiator section, high pressure to increase temperature differences, superheating a part of the water circulation, and creating a condensing steam and introducing steam into a main riser pipe at the top of a circulating system. It's common to find one or more pumps as the main method of circulating. All right. All right, so hydronic furnaces, okay, is one that has water heated up initially by a boiler or a water heater, and then it's circulated through a heat exchanger inside the furnace's air handler. So what essentially that means is you have a boiler that's heating your water. But instead of having baseboard and radiators, it'll go into the furnace cabinet, go into a heat exchanger with a coil, and then you blow the cabinet air across, and it will supply it through the air ducts. All right, which is a very efficient way to do things, and we see that a lot too. Um, so, the blower fan works with the like usually typically work with your air handler, or cooling system as well. It's usually sometimes referred to as a hydro air heating system. Okay. And then also now that we have these tankless water heaters, you can have a combination water heater produce hot water for heating and for your hot water, domestic water, and for your burner, for your heating system. Excuse me. There's either a tank or a coil immersed inside the hot water of the boiler. The water or the boiler directly heats the inner tank. So when you have a burner, all right, you can have also what's called a tankless heater in there too. So it's a coil inside the burner, wraps around, and that will use the burner to heat your hot water as well. The boiler water is transferred by conduction to the water supply inside that coil. All right. So back on those expansion tanks, right? So expansion tanks are necessary, right, on the hot water heating systems because of that hot water expansion, like I said. Um, And it's installed obviously above the heating system because the heat rises, right, with the water. There's a valve on top of it, okay? And you can see that's where I was saying with the air on the top half, you will have like an empty sound, and the water on the bottom half will have obviously that that thud sound. Um, pipes of the hydronic system, right? You could see throughout the house, right? When you look at your hydronic system, most of the time you're going to see copper piping. You could find cast iron, wrought iron, steel, right? Galvanized steel they used to use, PEX or plastic, and the diameter of those pipes are going to vary. So obviously, when you have cast iron pipes, they're going to be much thicker than if you have copper or PEX style pipes. Typically, you'll see 3/4 for PEX and copper, and then if you go up to wrought iron or the cast iron, it's going to be 2-inch pipes. All right, so when you have a radiator system, right, that's called what's called convection heat. All right, so we talked about in the beginning, um, and they use circulating pumps are used to circulate hot water in a hydronic forced hot air system. They push the water through the piping system. The pump should be placed in the correct position on the heating system in order to be effective. Um, and then the heat emitting units are the radiators. Okay, so the baseboard convectors and other units, right, will transfer that heat into the room spaces. Cast irons are very typical or common in older homes, all right, that you see. A lot of times people build these nice boxes over them, but sometimes they're restricting the heat in them. So you got to be careful of that. You want to make sure that there's enough airflow around them as well to get that heat out. Because if you block them or cover them, it's not going to emit the amount of heat that it's designed to do. All right. Then you really want to have an opening when you have like the baseboard style radiators at the bottom. Okay. So you never want to have people, sometimes they roll the rugs up underneath them. Again, that's blocking the units. You want to make sure that they're free and clear at the bottom, and again, free and clear at the top so the air can come through and radiate into the house. Um, Electric hydronic heating systems may be used to heat the water. Okay, it's another thing that as we get more green that they're trying to do, and usually very compact, very small boilers, and they come in different sizes, but pretty simplistic units. It's just hangs on the wall, plugs in, water runs through it, heats it up, sends it out. All right. Advantages of hydronic heating. Um, the heat is uniformly delivered. So unlike in forced hot air, there's less energy used again too to circulate the water through the pipes than is needed to circulate air through a duct because you need a big blower system to get all that air pushed out. The water will just push itself with the unit. Um, it's easy to zone water heaters. You can make every room a separate zone rather than with forced hot air. You'd have to have electronic dampers on different units. Um, and also, there's less issues known for air quality, okay? Because the pipes are heating the water, it's inside there, and it's just using what's in the house. Rather than there's ducts, there's the heat exchangers, condensation can happen within them. So there's more potential issues with forced hot air versus when you have the hydronic heating systems. All right. So control devices. So when you're looking at your boiler, typically you're going to see a temperature and pressure gauge on that unit. Okay. If you ever see it's down at 0 and 100, at 0 at both and not at like 100, like it's showing, the unit is probably off. Okay. There's also above that, you'll see the aquastat. So what that does is that's where you set the temperature of the actual boiler. Okay, to fire up when it gets too low and when it gets too high to turn off. There's also the high temperature limit switch, okay? And then there's also a pressure relief valve. So you can see the bottom here, you have a pressure relief valve. It's a little rusty. you want to comment to make sure that that's there because that protects the internal heat exchanger inside that unit. All right, so in the event that there's too much pressure or too much temperature in there, too hot a temperature, it will release that to help protect that unit. Because it is a sealed unit, you don't want to put any excess wear and strain. So that's why that is there to protect it. That line also, you can see where his hand is discharging that water. You want to have a discharge tube on that goes to the ground and 6 inches, no more than 6 inches above the ground, because in the event that that water does discharge, it's most likely going to be very hot, and you don't want to get scolded if you have to turn the unit off in an emergency and get too close to it. All right. So steam and hot water boilers look very similar too. You will see there's a little glass tube on a steam boiler, and it'll have a little water level in there. Okay. And they operate and heat the water obviously and turn it into steam. Hot water boilers operate 6 times that of a steam boiler. And they also have a low water cutoff steam boiler because in the event that there's not enough water in the unit, right, it's just going to overheat those heat exchangers and damage them. All right. So safety control is super important. Again, we're not going to be checking and testing those safety controls, but it's good to understand how those boilers do work. Steam boilers should have, like I said, the water level gauge, a water cutter, low water cutoff, a pressure gauge, a safety relief valve, and a high pressure limit, similar to a hot water unit. All right. And I always just check to make sure that before I fire up that unit, the steam boiler, that there is water in that, and to make sure, because you never want to rely on those safety units when turning them on. So you want to make sure that there's a water level in that glass uh, stem. Also, too, if you see the water is like black or rusty, it's an indication that the system needs to be serviced. There are two types of steam heating systems. There is a low pressure and there's a high pressure unit. And the type's going to depend on the operating pressure of the steam in the system. So low pressure steam systems typically are set to 0 to 15 psi's, and high pressure systems will exceed that 15 psi's. You usually find low pressure systems installed in residential homes. High pressure systems are going to be more installed in buildings, high rises and things like that. All right. Hot water boilers, okay, have a variety of valves, controls. We talked about all of them. The aquastat. There's usually an air vent too, you'll see. And sometimes you'll see them leaking. So it's a little silver cylinder, and you'll see them dripping sometimes. Again, that's an indication that the unit just needs to be serviced. Right now, with turning a lot of the heat on here in the Northeast, we're running across a lot of problems with the boilers, either the TPRV valve starting to drip, the high pressure valve, air vent is leaking. So not uncommon when you first start them up. So you want to, again, check for that pressure relief valve, right? Want to make sure that that's installed properly and has a leg on it. Because if that is not installed properly or capped, the system can actually explode because there's so much pressure that will build up in this, right? It's a relief valve. Um, And then also on your units, there's also going to be on the lower section of them, there's usually it's called like a blowdown valve. And that's going to be, again, not something that we use, but it'll be a valve there that they use to clean the boiler, right? Remove any sediment that will build up. So when you're heating water, right, all the sediment like will fall to the bottom of that unit. So you want to have that serviced and cleaned out because that'll build up. If you ever try to boil water, right, in a pot, right, you put the pot directly on the heat. Imagine taking all that sediment right at the bottom of your boiler and try to heat it. Take a brick, put it on your oven, and then put the pot of water on it. That pot of water is never going to boil. So that's why it's important to have these units serviced and clean them out and blow them out. All right. Pressure reducing valves or pressure relief valves. Most hot water boilers have water pressure reducing valves, which feed water into the boiler automatically when the pressure in the system starts to drop. Keeps the system automatically filling up with water, and it's installed on the cold water supply. Older systems may have a manually operated feed valve, and is usually set to feed water to the boiler at about 15 pounds of pressure, which is usually sufficient for a house no more than 3 stories high. Um, on a low pressure boiler that you may find in a home, the pressure relief valve is set to open at a pressure of 15 psi's. The pressure relief valve should not be rated higher than 15 psi's. Um, you don't want the boiler to rupture under any, additional pressure. You want the valve to activate before that happens. Pressure relief valves that are installed on hot water heating boilers will open under two conditions: water thermal conditions and then steam pressure conditions. These relief valves are used to protect against any damage to the property or injury to people. All right. Or into steam boilers. Identify and describing your heating system, right? Again, with a steam boiler, you want to identify that it is a steam boiler. Okay. I like to identify the make, the approximate manufacturer year. Um, and then you'll have your multitude of types. So again, there's a similar in the hydronics, you'll have a gravity fed, a one pipe, a two pipe, a steam boiler. You have like control components, right? So again, with the gravity fed, they're usually bigger and they're gravity fed, and the condensates return to the boiler from the radiator systems by mechanical means, right? The one pipe is just one unit and it runs to all the units. And as the hot water gets cooler, it just comes back to the unit, heats up, and continues to circulate. Then there's the two pipe, which is they're individually fed, right? So each heating baseboard or radiator will get its own hot water. Then that will directly return back to the boiler as needed. Steam boiler heats the water until it boils and it changes into steam. Steam can run on various types of fuel, and steam comes boilers rise up through the pipes and enters the heat emitting units. The design and construction of a steam boiler is very similar to a hot water boiler. Okay, so they can be gas fired or they can be oil fired. Okay. Um, There's one significant difference on a steam, sorry, is a Hartford return, okay, or called a Hartford loop. And that's installed on the condensate return line. It prevents the total loss of water from the boiler. So when you're heating that and it's steaming up, you want to collect as much condensate back to the boiler, to keep that water at a operating level for the steam boiler. There's also steam traps. Is this device installed on a steam line that controls the flow of the steam, air and condensate. It automatically opens and discharges air and condensation, and it will automatically close to stop the steam from escaping. Pumps sometimes are used on heating systems to handle the condensate and discharge excess air. All right, and you'll typically see with steam, you'll have radiators. All right, which is common, or you can use like and convectors. All right, convector primarily uses convection to transmit the heat. A convector is used made of a tube and it has fins attached to it typically. All right. All right. So steam boilers are not completely full of water. They're only about 75% full. Again, you need to have proper water, but you also need to have proper space for it to boil and make the steam. Steam boilers run about 2 psi's. Hot water boilers operate about 12 to 15 psi's. Um, there's also a backflow preventer. Okay, so the unwanted mixing of the water supply to the boiler and the domestic water supply of the boiler. So you never want to have the water from the boiler come back to your domestic water. Um, the efficiency based on several factors, so including obviously what type of fuel you're using, the method of the firing, the control settings, and that AFU fuel utilization rate, right? The minimum, right, is 80%. Um, for and mid efficiencies is 80% to 83%. High efficiencies is 90 to 80, 98%. And conventional condensing steam and heating units are 60 to 65%. So those are the minimums based on those types of units. Right, there's an air separator trap that removes any air bubbles, okay, from the water in the boiler system. When a hot water system, heating system is filled with cold water, the water contains some air. Air bubbles are created when the water heats up and moves rapidly through the pipes. All right, and it gets trapped the air. So you want to get that air out because what happens is there's too much air in the unit. You'll see the radiators will start to fill up and start to heat, but then half of them won't, and then it won't cycle through the rest of the system. And then what happens is you're not going to get evenly or enough heating throughout the house, or you might only get heating in one or two of the heating systems. Again, common here in the Northeast right now, we're starting to fire up everything for the first time, and we're running into some of the radiators aren't working, or especially with the steam boiler. So it's usually just an indication that they need to be bled. Again, it's not something as a home inspector we're going to be doing, but it's something you can let them know. Hey, we ran through the system. We had X, Y, and Z worked, but these other ones did not operate. So to definitely check that. All right. There's also a balancing valve, and that's used to balance the heating system. It can also be determined how much water is flowing through the valves. All right, so electric heating systems. An electric boiler may be used at a home's main heat source. Electric boilers are compact, they're insulated with heating elements immersed in the hot water of the boiler. Inside the compact electric boiler unit are all the components, including the expansion tank, pump, valves, and controls. Um, at an electric forced warm air heating system, heat is forced through to rooms and spaces of the building by the use of a blower fan and ducts or pipes, and they have zero clearances. They can be installed horizontally, vertically, and in as tight or little a space as you have. The furnace is controlled by a thermostat. A blower fan is installed to force air through the heating elements. Electrical radiating heat sources. Common type of electrical radiating heat systems is one that is capable embedded in the floor, wall, or ceiling. The heat that is created by the cable is transferred to the occupancy and surfaces in the room by low intensity radiation. There are three types of radiant panel systems: radiant floor panel systems, radiant wall panel systems, and radiant ceiling panel systems. Electric baseboard heating systems are another one you'll see out there. They're usually installed at the floor level, so you'll see it at the base, typically like a regular baseboard that's hydronic, but it'll have its own either thermostat on it or it'll have a thermostat on the wall. Okay, and heat is transferred through a metal electric fin. Again, air comes through, comes out the top, and heats out through that. Probably the most common type of electric heat you're going to see is the electric baseboard. Heat pumps, all right. So obviously they're catching a lot of traction, especially of late, and especially here in New York. Heat pump is an electrically powered system that is a reversible refrigeration cycle, and it's capable of doing both heat and air conditioning for the building. The source is either air, right? So the heat pump uses the air or water to heat up the water and then run through. The most common type for residential installations is the air-to-air heating system, but they do have water. All right. So we got Jim here. He's going to go over inspecting and air conditioning, and I'll pop this on. You guys can watch that.
Inspection standards of practice, the home inspector shall inspect the cooling system using normal operating controls. The inspector shall describe the location of the thermostat for the cooling system and the cooling method. The home inspector shall report as in need of correction any cooling system that didn't operate or if the cooling system was inaccessible.
Okay, we're starting section 3.5, cooling. First thing we need to do is make sure that the air conditioner is warm enough to operate. We've had some snow recently, so unless it's sitting in the sunshine, it probably isn't going to work. So what we do is we shoot the compressor. Make sure we're at least 65 degrees. We're 84, so we're fine to run this air conditioner. So we're gonna look here, electrical wise. Because this air conditioner is within sight of the electrical panel, we're not required to have a service disconnect. Otherwise, we'd have a service disconnect at this electrical. We're gonna look at the refrigerant lines. Do we have insulation on it? Does this look good? Does the air conditioner look level? And are our fins relatively clean? You know, we have a little bit of leaves. It is, fall here. A lot of times people will put a cover on. So now this is a carrier, it matches the furnace. It's a Puron, so it is a 410. So it is a newer style refrigerant. If it used R22, we note that in the report because R22 is now getting very difficult to find and very expensive. So on the back side, again, we're going to take a picture of the data tag. It's not going to go in the report, but it basically proves what we inspected. On this data tag, it gives us a minimum and a maximum breaker that we should have for this air conditioner for protection. When we do the electrical section, we're going to make sure that the air conditioner breaker matches this data tag. So now that we know we're warm enough to run, we'll go back to the thermostat, we'll turn on the air conditioner, then we'll come out and see how it sounds. Okay, coming outside, we turn the thermostat on. So when we come out here, the fan should be working. We want to listen to how it sounds. We should hear both the fan and the compressor humming. So far, it looks really good. Again, looking cleanliness, it looks good. As this runs and gets hot, we will get warm air coming off the fan. Over on this side, after this has been run for a while, we should have a cold suction line and we should have a hot, high pressure line. You can actually hit them with your infrared and check the differentials, but just by hand, you can easily feel the difference. That gives you an idea about charge if it's working. So this line will be hot. This is the muffler, keep things quieter. This line will be cold. As it runs, once it warms up, then we go into the house and we check our differential between our return side and our supply side at the registers and just get a good idea of how well this is working. Okay, after we've ran the air conditioner for about 20 minutes, we're gonna come and we're gonna check our return air, and then we're gonna check one of our supply registers. We wanna see 13 to 16 degrees differential. So we actually documented in a report what it is. Now, if the temperature is close to that 65 or 70 mark, we're also going to put a note in our report that due to the exterior temperatures, cooling efficiency could not be fully tested, inspected, because the air conditioner doesn't have to work very hard on a cooler day. But if you check the differentials here, if you check the differentials at your lines at the compressor, you will have a pretty good idea if it's functioning properly. Go back to the thermostat, going to turn off the air conditioner or set it back to where they had it. Okay, this house, just like most residential properties, uses a split air conditioner. So outside, we've already looked at the compressor and the condenser. Inside, we have an evaporative core, or most people call it an A coil. You can't see it, it's behind here. This is the line set that comes from the exterior unit. So we still should have our differentials, warm, cold. In here, this is what cools the air for the house. The furnace now functions basically as an air handler. We use the blower. We blow air past that cold A coil. The air absorbs the cooling from that coil and blows cold air through the house. So we're using the same register. So we've already checked those in the heating section. We don't need to go back and check our HVAC registers again. We already know we have proper flow. We should have a condensation drain system, and it needs to go somewhere near a floor drain or have a reservoir pump. I would write this up as it discharges onto the floor, so it's leaking there. But we want to make sure that we have our drainage system. If this is above a finished area of the house, typically we want to see a catch pan for secondary condensation. But, so this is the interior portion of the air conditioner. The outside had the compressor and the condenser. So we're just finishing up the air conditioner, the cooling section of the inspection. So now we're gonna start on 3.6, which is plumbing.
All right, so we'll go over air conditioning. Okay, so air conditioning isn't just as simple as like cooling air, right? It's going to include many different aspects. Include like heating, cooling, humidification, dehumidification. So all that goes into an air conditioning unit, right? So humidification obviously is the addition of moisture. Dehumidification is the removal of moisture, which is important. All right. The rule of thumb, right, for like sizing air conditioners, again, doesn't pertain to us as home inspectors, but it's always a good rule of thumb. So 1 ton of refrigeration for each 5 to 700 square feet of floor area. So a ton of refrigeration is equivalent to 12,000 BTUs. So just for like a rule of thumb, so you know when inspecting a house. All right. But not something that we need to comment on. So, the most common types of air conditioning systems in most homes is referred to as a direct expansion, mechanical. It could be gas compression or vapor compression refrigeration systems. This systems can consist of an indoor coil, just like we saw with Jim, an outdoor condenser, and a compressor. A typical type of air conditioning systems installations is a split two-part system where the compressor cools all the air outside or uses that to cool it. And then you have the unit located inside with the evaporator coil, the fan, and it's usually in conjunction with the heating system inside the house. All right. So here's your refrigeration cycle. Okay, so this isn't a gas compression type unit. So you can see you have the expansion device, the condenser, the compressor, and the evaporator. All right, so as an evaporative cooler or like as it goes through everything, the compressor acts as a pump, pushes the liquid refrigerant into an expansion device. The refrigerant is then under high pressure. Okay, and then it expands that's located in the evaporator coil. The expansion device controls the flow of the refrigerant, and this device can be an expansion valve, or sometimes it's also a capillary tube. As the high pressure liquid refrigerant is forced through the expansion device, it expands into a larger volume in the evaporator coil. When it expands, its pressure is reduced and its boiling temperature is now lowered. Under the lower pressure, the liquid refrigerant boils until it becomes a vapor. During the change of state, the refrigerant absorbs heat from the warm air and across the evaporator coil, and it blows all that through, and that's where you get your cold air through it. All right, so your air conditioning, your system, right? Here's your heat pump efficiencies. So obviously, as heat pumps got more, became more of a figured out thing, the efficiency has gone up on these units. All right. They weren't as efficient as they once were, and now they're becoming way more efficient with reference to having them as your main heat or cooling unit. When an air conditioning is running, the house air may have a temperature drop of around 14 to 22 degrees as the air moves across the evaporator coil. So Jim showed you in that video to test those temperature differentials. And we like to notate them in our report, right? We have proper temperature differentials, or if we're not having sufficient cooling, we like to note that. The efficiency of a cooling system is rated in SEER, and you want to have a SEER rating of at least now the newer systems 13 or higher. And that was in 2006. They mandated it, right, and could no longer make equipment with a SEER less than 13. And then 30% increase in minimum efficiency from 10 to 13 could result in energy savings up to 23%. So pretty big, depending on what your SEER rating is. The compressor unit is a pump. and it's located inside the outdoor condensing unit, and it receives the low pressure refrigerant and the suction line and compresses or squeezes it into a volume at the high pressure, and then sends that into the refrigerant flowing through the system. Um, so you don't want to operate that system obviously below 65 degrees because it can damage your unit. All right. And if you have like 165-degree day, you probably want to wait till you have a couple days at 65. I at least wait till 3 to 5 days that we've had warm weather to run those units. All right. Because what happens is the oil with the refrigerant isn't mixed now. It's too cold, so it solidifies at the bottom of the unit. All right. Many air conditioning systems do have a heater or a sump heater or a crankcase heater installed on the bottom of the compressor. The heater keeps the oil in the base of the compressor warm enough to help boil off the refrigerant. The heater may be internal or visible on the outside of the unit. The condenser in a typical air conditioning split system is located outside, and the condenser will help liquefy the gases by cooling it. When the condenser is running, hot refrigerant gas coming from the compressor enters the condenser coil, and as it passes down through the condenser coil, it cools it. And then the compressor obviously is located within that condensing unit outside. And that unit, you want to make sure that there's no vegetation around it. Like Jim said, level, because that unit is pulling in that air to help cool and condense that refrigeration. All right, so the evaporator, some call it the evaporator coil, cooling coil, or indoor blower coil, has a couple different names. Typical in residential construction, that evaporator is what absorbs the heat from the house. Okay. So you're not actually making cold air, you're removing the heat. That's what the air conditioning unit's actually doing. And it just transfers that heat by passing air to the refrigerant moving inside as a liquid. And it helps absorb that heat. Evaporators are usually made of copper tubing, and they're very fine, close together with aluminum fins. Um, it's sometimes called an A coil, like Jim said, and that's because of the shape like an A. All right, that's in the unit. Some coils are just slab coils because they appear like a slab tilted at an angle. Coils have a condensate tray underneath them because, again, when it is absorbing that heat, there is condensation, so the water drips off into the pan. So it is common to see that, especially in the high heat months like summer, and high humidity days. R22, like he said, you want to note that if you see that in the systems, it's become very difficult. It's not environmentally friendly. We've switched over to obviously R410A, which is what they're using predominantly now. R12 is an even older unit, which I don't know if you even see that anymore. I don't think I've ever seen that. But R22 we do see. All right. Um,
Just to let you know, Dan, we have about 5 minutes left.
okay, no problem. So expansion devices, capillary tubes too. They can be either or. All right, and the capillary tube is a coil of a small diameter tubing, and that helps restrict or bottleneck up that liquid. And that's what creates the pressure and the change in temperature inside those units. A thermostatic expansion valve is another expansion device. It's a little more precise than the capillary tube, and it controls the flow of that refrigerant. All right, the refrigerant piping is what runs. It's usually a copper tubing, and that runs from the exterior unit, the compressor, to the evaporator inside. All right, they're called refrigerant lines. There's a suction line from the evaporator coil inside the house to the compressor, and then the suction line carries the vapor. The liquid line is the pipe from the condenser coil to the evaporator, and that carries um, not the vapor, the liquid. All lines should be checked for any damage, bending, insulation, and make sure that they're all in good shape. You can check them too when they're running to make sure that one side is cold, one side is hot. You will see them condensing if the insulation is missing. Again, it's important to keep that insulation on there, and that will allow for a proper efficiency of the unit. Um, a filter dryer, all right, that removes particles from the liquid refrigerant and from the oils. And that just helps keeps the expansion tank, I'm sorry, the expansion device, capillary tube, and expansion device clean and free from any issues. There also should be electrical disconnect, which Jim talked about in his unit. So you're able to readily accessible remove the disconnect from that unit to service it or turn it off in the event of an emergency. Okay, heat pumps. So heat pumps, three different types of heat pumps, right? There's air source, ground source, heat source, and water source heat pumps. Most heat pumps used in residential and light commercial are split systems, just like your regular style air conditioning units. All right, it has a compressor outside, and then it has a evaporator inside. Um, an air source heat pump is often called an air-to-air heat pump, which uses the outdoor air to the source for the heat. It uses the indoor air as a source from which to absorb the heat energy. It takes that heat energy from the outdoor air and transfers it to the interior air of the building. The problem with air source heat pump occurs when the heat pump is operating in the cold wintertime and there's very little heat energy in the outdoor air due to low outdoor temperatures. And that it is the same time that you want the heat pump to produce the most heat. For this reason, they don't recommend air source heat pumps as your primary source of heat. Air source heat pumps, heating cycles, they evaporate the refrigerant in the outdoor coil. As the liquid evaporates, it pulls heat from the outside air. The hot air gas is compressed and pressurized as it passes through the compressor to the indoor coil. Then it's condensed to the high pressure liquid, releasing heat to the inside of the house as it's cooled. All the same as obviously your regular type systems here. All right. There's also the ground source heat pumps, sometimes called the geothermal pump. Again, there's not much that you're going to check with the geothermal pump, excuse me. It's usually a heat exchanger that is located inside the ground and it uses the groundwater to pump up and then brings through those heat pump cycles. It's an extremely expensive system to install, much more than like the air source heat pumps, but very efficient and cost effective or efficient and energy savings to run, right? Because it uses the groundwater. So there's usually a pump involved in it. And there's also usually a water storage located as well. All right. In the cooling cycle, the valve reverses in these heat pumps. Okay, so the pressure pumps the refrigerant in the opposite direction as when it's in the heating system. All right. There's also a defrost cycle when a heat pump is operating in the heating mode or heat cycle. The outdoor air is relatively cool, and the outdoor coil acts as an evaporator. Under certain conditions of the temperature and relative humidity, frost may start to form on that, so you might see that in extreme cold. Um, the frost must be removed as the heat pump has to go through that cycle to remove all that the frost, because what's going to happen is if it frosts up, it's not going to transfer that heat and it's going to stop working. All right. So it's an integral part of it. Um, During a defrost cycle in an older heat pump, the indoor units may be operating with the fan blowing cool air. To prevent cool air from being produced and distributed inside the house, an electric heating element can be installed and engaged at the same time as is in the defrost mode. So you're still getting heat source while the unit outside is defrosting itself, so it can produce hot air for you. All right. There's many reasons for the frost that can happen. It could be a bad valve, coil, wiring problem, thermostat. So it's not us to diagnose that, but you want to comment on it and let them know that, hey, the unit is frosting up and it needs to be serviced. When you have your units, you want to definitely take a look at the air filters, make sure that they're clean. You want to notate that. Okay. Sometimes there are those electrostatic filters, the self-cleaning filters. Again, there's nothing that we do with them. I would just notate that they're there. or washable filters there. All right. I do always like to show the clients the filter. Hey, once every 3 months, this filter should be replaced for proper air quality in your house. It will also allow for your unit to run much more efficient and effective. You never want to double filter either. You never want to have two filters in the unit, so you want to check and make sure that double filtering is going to reduce the airflow across the unit. And you can get air filters obviously in all different shapes and sizes. So that's why I like to take a picture to let our clients know which air filters they have. Appreciate it, everybody. Have a great day.
Good night, everyone.
Night.